far with presentations on waste management, sustainable building technologies, and energy management respectively. We hope you have a very enlightening and interesting day today. Before we begin, I would like to notify the participants of the usual instructions. Kindly switch off your audio and video during the sessions. Switch it on only upon request of the facilitators of the FDP. This is to ensure smooth and undisturbed sessions. Kindly note that all queries and doubts can be dropped in the chat box and will be taken up by the moderator at the end of the session. Upon request, the participants can raise their queries themselves as approved by the facilitators. Please ensure that your audio is connected and working for the same. Kindly ensure that you interact with the speakers as they have questioned the active participation and interaction of the participants. At the end of every session, a Google form for attendance will be shared in the WebEx chat. Please fill it up to be marked present for individual sessions. Kindly notify us if you don't receive the form links before the commencement of the next session. Let us commence the day of 8 of the FDP. I extend a hearty welcome to the speakers for the day and all participants. Without further ado, let us begin this session with Dr. Sunil Pandey. I now invite Architect Leah Lloyd to introduce the first speaker of the day.
Thank you, sir. Dr. Sunil Pandey presently is a Senior Fellow and Director of Environment and Waste Management Division, TERI. In addition, he also teaches at TERI School of Advanced Studies. He has more than 30 years of consultancy or research experience in the area of municipal, industrial, and hospital waste management, plastic waste management, waste to energy issue, impact assessment, air, water, and soil quality monitoring, site assessment, performance evaluation of ETP, and institutional strengthening and capacity building. He has obtained his PhD degree in hazardous waste characterization from Nagpur University while working as project fellow at MERI, Nagpur. He has his MSc in analytical chemistry and BSc in chemistry from Banaras Hindu University, India. Prior to TERI, he has also worked at ERM India and University of Hong Kong on hazardous and hospital waste management. We welcome you, sir, to the day 8 of FDP. Sir, over to you.
Thank you very much and for kind introduction and good morning to all of you. Let me start by sharing my presentation. I hope you all can see my presentation.
Yeah. Yes, sir. Sure.
Full screen mode now. So what I have decided, I thought that let me discuss two sectors rather than going in all the sectors. One is healthcare sector. What are the issues and challenges, and related to healthcare sector, because healthcare sector generates almost all kind of waste, which is solid waste, which is considered a hazardous waste on how hazardous waste has to be dealt and how what are the current issues and challenges relating to hazardous waste management. So as first part, I'll start with waste management in healthcare sector. When we say healthcare sector, healthcare sector generates municipal solid waste as a majority, but a smaller amount of biomedical waste and still smaller amount of hazardous waste. But because of very infectious characteristics of biomedical waste and toxic and hazardous characteristics of hazardous waste, it becomes very important to deal with them in a proper manner, and that is why we need to look at how we manage biomedical waste. And as the name suggests, basically it's infectious waste and infection-related waste which is coming out of healthcare treatment facility. If you look at regulation-wise, the series of regulations were initially notified. Biomedical waste rules, other than hazardous waste rules, you'll be surprised. That was first waste management rule after hazardous waste management rule, which was notified in the country. The first time the rule was notified in 1998. Surprisingly, I mean 2 years before the municipal solid waste rule was notified. So that shows how much importance government at that point of time accorded to need to manage biomedical waste waste in a proper manner. The latest notification on a biomedical waste rule is dated 2016, and all these rules, all the waste management rules, basically are notified under EP Act. EP Act basically is the Environmental Protection Act of 1986, which is essentially an umbrella act covering all the acts and rules within it. And rule since notification of 2016 has been amended to accommodate certain features of biomedical waste management rule, which I'll discuss subsequently. Those rules were amended in 2017, 2018, and subsequently in 2019. But important issue here is when you look at these rules, the amendments have to be looked into with the parent rule of 2016. So that's an important observation here. This rule is applicable to anyone who generates. When we say generators are essentially hospitals, healthcare facilities, pathology labs, testing facilities. So all those become generator. Collect biomedical waste, receive, store, transport, treat, dispose, or handle biomedical waste in any form. And it gives you a range of healthcare facilities. Earlier, the range was not so wide, but now they have included almost anything relating to healthcare into generators. They include hospitals, nursing homes, clinics, dispensaries, veterinary institutions, animal houses, pathological laboratories, blood banks. Ayush hospitals now also are included under biomedical waste facilities. Clinical establishments, research or educational institutions who are doing research on, say, in COVID times, in COVID, but otherwise on other diseases, health camps, medical or surgical camps, vaccination camps, blood donation camps. Earlier, I mean, these camps were not part of biomedical waste rules, but now they also have to manage their waste in accordance to biomedical waste rules. First aid rooms at schools, colleges, forensic laboratories, and research labs. So that shows, I mean, that gives you a very wide range of applicability of the biomedical waste rules to entities who are generating biomedical waste. Occupier, by definition, if you look at waste management rules, are the ones who generate waste and store waste at their premises for a certain period of time till they are taken away for treatment and processing. So by definition, that's the definition of occupier in the biomedical waste management rule. It's the same definition in other waste management rules as well. So what is the duty of occupier? One who generates and stores biomedical waste for an interim period till it is further processed. Collection of biomedical waste rules in specified bags, and I'll come to that. What are the specified bags or containers as mentioned in Schedule 1 of the rule? To be transported directly to CBWTF is essentially, it's called Common Biomedical Waste Treatment Facility. So waste treatment facilities which are common, which are located almost in all states and established by states, where the healthcare facilities generating waste in their premises need to send their waste for treatment and processing. Of course, against a user charge. Pre-treat bio-waste, bioactive waste, because certain type of biomedical waste are very active microbially or biochemically. So they need to be stabilized before they are sent to common waste facilities. And as per guidelines of WHO or National AIDS Control Organization, NACO, they have given some guidelines on very infectious type of waste. They cannot be straight away sent to common facilities for treatment. Rule also, importantly, for the first time since other rules initially, older notifications initially were not mentioning. Okay. Is that all right? Can you hear me all
Yes,
right?
sir. Sure.
Okay.
Yes, yes, sir.
I thought there's a problem. So importantly, this rule also says that chlorinated plastic materials which were used in healthcare treatment, in terms of tubings, in terms of blood bags, in terms of other bags, they need to be phased out within 2 years' time of notification of rule. And there are certain exceptions in terms of chlorinated plastic bags, the way it is defined in the rule. And they will not include urine bags, effluent bags, abdominal bags, chest drainage bags, because which is as per amendment of 2019, because as of now there's no viable alternative for them. And why these chlorinated bags are to be phased out? Because of the fact that the polymer contains chlorine, and if you burn them in the incinerators, it results into release of dioxins and furans, which are very hazardous gaseous emissions. So idea is to if you phase these out, then other waste can be incinerated safely. Establish a barcode. Rule says that you establish a barcode for all the containers and bags which you produce and which you sorry, kind of use in treatment, so that they can be tracked. Training, immunization, and regular reporting of status of training, and immunization of healthcare staff, workers who are engaged in biomedical waste management. Separate collection of solid and liquid waste stream. So solid and liquid waste streams are not to be mixed together. Other than occupier, there's also certain elements of on the duty of operator of the common facility, common waste treatment and disposal facility. I'm covering the key elements of the rule, not the basically what are the other elements in the rule. So what occupier of the common facility needs to do is timely collection of the waste, ensuring that barcoding is done properly, and GPS, implementation of GPS system for transportation within 1 year of the notification of rule, so that any vehicle which is transporting biomedical waste is properly tracked, and they don't indiscriminately dispose waste here and there. Take authorization for collection, transport, and storage from the State Pollution Control Board, and dispose and operate according to the authorization which is given by State Pollution Control Board. Training and capacity building, providing need-based support to occupiers. So also one of their mandates is also to enhance capability of healthcare facilities, to train their say paramedical staff, nursing staff, hospital doctors who are engaged in day-to-day management of these facilities. Maintain record of recyclable waste. Earlier rules were not, they suggested that no waste generated from biomedical waste facilities should be recycled. But now 2016 notification has allowed recycling of waste, provided it is properly disinfected. If waste is not disinfected, then it is not recycled. But if it is disinfected properly, then it can be recycled into new material. Then there's a provision, special provision for handling of mercury and lead-bearing waste, because mercury and lead are very hazardous and toxic constituents in the waste, and there is a separate regulation on lead and mercury in hazardous waste rules, which is applicable for dealing with such waste. Lot of instruments, lot of radiation shielding material, lead is used, and for say blood pressure equipment or thermometers, mercury is used. So all these has to be dealt with those regulations. Sterilization of microbially active waste to the log 6 or disinfection to log 4 is required before bioactive waste can be further processed and treated. No occupier to establish a treatment and disposal facility if there is another treatment and disposal facility in the 75-kilometer radius. And this provision is to ensure that a common waste treatment facility which is created gets a proper amount of waste generated from hospitals, and they can operate at the maximum capacity. This is Schedule 1. Schedule 1 essentially tells you the type of containers and bags which are recommended for different kind of waste. For example, yellow bag or yellow container, the type of waste which needs to go there is basically human anatomical waste. I'll not go through details, but you can kind of quickly go through this. And yellow waste, yellow bag or yellow container, essentially the treatment option which is proposed for human anatomical waste and animal anatomical waste is in either incineration, plasma pyrolysis, which is a step above incineration, or deep burial only in the areas, especially rural areas where such facilities are not available. Otherwise, deep burial is not allowed in the urban areas. Yellow containers or bags also are required to store soiled waste, which are contaminated, say with healthcare treatment systems, contaminated with blood, body fluid, dressing, plasters, etc. They also need to be incinerated or treated with plasma pyrolysis. If these facilities are not for some reason available in certain areas, then soiled waste can also be autoclaved or microwaved to make them sterile. Expired and discarded medicines also need to be stored in yellow bags. And chemical waste, chemicals which are used in laboratory and testing, also need to be going into yellow bags. Yellow colored bags or containers, and non-chlorinated, because these bags are to be incinerated. Here, for date expired medicines or expired and discarded medicines, there is a strict instruction that it should, if the expired medicines are cytotoxic drugs, which are dangerous items, if people are exposed to them, then they should be either sent back to suppliers, manufacturers who supply them, or they should be incinerated or treated by plasma pyrolysis. No other method is recommended for that. Chemical liquid waste, no bag is suggested for this, because liquid waste is to be treated separately. And the sources from generally where chemical liquid waste is generated is, say, for example, X-ray facility where film development is done, or pathological labs where testing is done. So this liquid waste has to be treated separately, sent out to effluent treatment plants. If there is any resource recovery which can be done, for example, in X-ray treatment facility, a lot of silver recovery at times is done, because silver is a precious metal. So recovery of such precious materials, and then it has to be sent to effluent treatment plant for treatment. Discarded hospital utilities like discarded linen, mattresses, beddings, they basically, they can be packed in large yellow containers. After shedding, after basically cutting them into smaller pieces so that they can fit in those containers, and can be taken for incineration or plasma pyrolysis. Similarly, a yellow bag also basically contains, is supposed to also contain microbiology and biotechnology and clinical laboratory waste. A treatment option which is suggested there is autoclaving in the bags to basically ensure that the waste is sterilized. And sterilization, if chemical sterilization is to be done, then it has to be done with non-chlorinated chemical sterilizers so that chlorine is not introduced. Then, other than yellow bags, there is a provision of red bag. And red bag, what red bag contains, should contain in the hospitals when waste is separated and stored, is contaminated waste, which is no contaminated, but after sterilization or after decontamination can be recycled and has a recycling potential. So waste generated from disposable items such as tubings, bottles, IV tubes, catheters, urine bags, syringes without needle, so they can be after disinfection stored in a red bag, and after disinfection can be sent either for recycling. If there is no recycler available, then they can go for energy recovery in the pyrolysis plant, or also can be shredded. And interestingly, rule says that they can go for road making, because a lot of plastics now is also used partially 10 to 15% replacement for bitumen into road making. White bag generally what is recommended is that white bag or white container should be translucent, should not be opaque, so that one can see what is stored in there. And waste typically which has to be stored in white bags are waste sharps in the treatment facilities. Typical sharp examples are needles, syringes, surgery implements, or any other sharp items which can actually puncture or cut when you are handling them and cause infection. White containers should be puncture proof, so that these material which is stored doesn't cause tear in them. Leak proof, tamper proof, and treatment process which is suggested after taking into treatment plant is autoclaving or dry heat sterilization, and followed by shredding or mutilation. And if it is a large amount of sharps, then they can be sent to foundries for disposal, for melting and recovering steel or metals. If it's a small amount, it can be stabilized with cement and disposed at a sanitary landfill. Then there's a provision of blue bag. So we started with yellow bag, red bag, white bag, and finally blue bag. What should blue bag contain? Glasswares, broken and discarded glasswares, medicine vials, ampoules. So all this material need to be, once they become waste, need to be packed in cardboard boxes and either kept in a blue bag, or a tape, blue color tape can be put there, so that one knows that all the broken glass items are there. Treatment procedure which is recommended is disinfection, and here you can use chlorinated disinfectants, because ultimately this material will go for recycling. No incineration recommended here. Blue bag also will store metallic body parts, metallic body implants, which can again be, after they become waste, removed and become waste, can be stored in cardboard boxes and taken for recycling and reuse. Another aspect, very important aspect of how biomedical waste will be identified when a person is transporting, is to use the label or symbols which are to be put on the waste containers, as well as on the transport vehicles which are transporting the waste. And there are two type of labels which are very important. Biohazard, the first label on your left hand side, essentially means that any waste which is being transported or being stored in these containers are biomedical waste and can present biohazard. Cytotoxic drugs, as I said earlier, cytotoxic drugs are very dangerous if there are cytotoxic drugs. And cytotoxic drugs has this black triangle with C written inside to show that the box contains cytotoxic material, which has to be not to be recycled or not to be incinerated, either incinerated or sent to manufacturers which are manufacturing these cytotoxic drugs. There are certain packaging requirements and certain do's and don'ts. For example, how cardboard boxes need to be packed when the waste is put in. When you see the first photograph, do not interlock flaps. Flaps have to be placed properly and then taped. Then flaps, when the box is to be opened and waste is to be kept there, flaps should go outside, not the inside, so that flaps are not contaminated with the waste when you're closing the box. And then the suitable colored bags is put. So another strict no-no is if you look at second row, no sharps should be sent to red bag. If by mistake, a lot of time sharps also are sent to red bags. There's no handling, manual handling of waste to create basically to densify the waste into container. If waste has to be densified, it has to be densified with proper precaution so that a person who is kind of compressing them is not in contact with these wastes. Then on the second row, last photograph is an example of a sharp container, a translucent container which is packed in red with all kind of labels and addresses. And this is how in the third row, a bag after it is full needs to be sealed with tape properly so that it is not the material is not exposed to environment. And many times for to enhance the safety, what hospitals do, they provide a double packaging. So one bag over the other bag to ensure that the waste is not in contact with people who are handling it. Waste collection is done in hospitals. When you see for the general type of waste which is generated in healthcare treatment facility, which is essentially municipal solid waste, a normal wheel trolley can be used. For example, a lot of catering is done in the hospital, a lot of canteens, then food to patient, the attendants who come also consume something, and whatever waste they generate, it can be collected in ordinary trolley. But the biomedical waste has to be collected in a trolley which is meant for that type of waste. If it is red bag, then red trolley. If it is yellow bag, then yellow trolley. White bag, white trolley. And similarly, black bag, black trolley. Then, just to summarize what we have kind of discussed so far. Yellow bag, human anatomical waste, animal anatomical waste, soil waste, discarded expired medicines, chemical waste, chemical liquid waste, discarded linen, mattresses, bedding, contaminated with blood and body fluids, microbiology and biotechnology and other kind of waste. Red waste, red bag, contaminated waste which can be recycled. White waste sharps including metals. Blue glassware and metallic body implants. And these are some examples of different agencies using different kind of and label of course has to be there in all these bags and containers, indicating that these are material with biohazard. Treatment options for biomedical waste category for yellow bags, incineration, plasma paralysis, expired cytotoxic drugs to be returned back to manufacturers. Chemical liquid should be treated in effluent treatment plant. Non-chlorinated chemical disinfection followed by incineration of plasma, and pre-treat and sterilize with non-chlorinated chemicals because you don't want to introduce chlorine in the material which you want to incinerate. Red bags treatment option is microwaving, autoclaving, hydroclaving, followed by shredding, and then sent for energy recovery or recycling. White, autoclaving, dry heat sterilization, followed by shredding or mutilation, and then either metal recovery or encapsulation for in cement concrete matrix for landfill disposal. Blue boxes, disinfection by soaking the waste glasses in the detergent and sodium hypochlorite, and then autoclaving, microwaving, and then sent for recycling. Now there are important suggestions on the biomedical waste in terms of how they need to be segregated, packaged, and transported. No untreated biomedical waste should be mixed with other kind of waste. You already know by bags type how these wastes can be segregated. They can be segregated, they shall be segregated at the point of generation and stored and collected and treated. Containers or bags should be labeled. Barcodes, already discussed. Common biomedical waste facilities, already discussed. Vehicle used for transportation should be registered under Motor Vehicles Act for transporting biomedical waste. So that is an important aspect. Not any vehicle should be employed in transportation. And then vehicle should be closed vehicle should be such that it can be sealed while storing the biomedical waste. And another important element, untreated human anatomical waste and waste which is bioactive should not be stored beyond 48 hours in the healthcare treatment facility. And it has to be within 48 hours sent to common biomedical waste treatment facility. This we have more or less discussed. And this is kind of a form which is provided in the rules, which are to be filled by waste generators and also waste managers who are treating biomedical waste, just to keep track of how much biomedical waste is generated year on year, and what is the status of treatment of this waste. Now, CPCB has compiled some status on biomedical waste treatment facility and also the kind of biomedical waste which is generated. So, as per CPCB reports, this gives you kind of how many healthcare facilities were there registered at that point of time, and how many basically, if you look at this flow, how many common biomedical waste treatment facilities were operating. So around 198 common waste treatment facilities were operating, and 24 2 years back was in implementation. And the amount of biomedical waste generated is estimated to be around 559 tons per day. Of that, collection treatment is around 518 tons per day, which is good. I mean, which shows that not much is going out of generation. We still have challenges because there are small facilities, say, for example, pathology labs, or small clinics, where tracking the waste still becomes a problem. But we have done good in terms of how much waste is generated and how much is sent for treatment. This is, kind of status of common biomedical waste facilities, how they have grown over the years to cover the healthcare waste which is generated in the country from 2008 to up to 2017. So as I said, generation is around 559 tons per day, 78% treated and disposed in 198 common waste treatment facilities, and rest in captive treatment facilities. Captive, when I say captive treatment facility, what it means is that some of the larger hospitals, for example, Apollo Hospital, large hospital, or AIIMS here in Delhi, they initially, when the biomedical waste rules came, they had installed waste treatment and processing facility within their premises. So they are allowed to treat and dispose some of the waste in their own facility, and that is why some of the larger hospitals still have captive treatment facility. There are 225 captive incinerators present in various large hospitals across the country. Many times what happens is these healthcare facilities actually are right in the heart of the city, and sometimes it is dangerous to take out waste from these hospitals and take out through crowded roads for common waste treatment facilities. So initially those captive incinerators which are allowed are still functioning and still operating and still treating the waste which are generated in these hospitals. So I'll kind of skip this. Waste transportation, you can see that such kind of vehicles are to be employed, which can be closed and which can be sealed properly. And inside you can see how different colored bins are stacked differently. They then from the hospital they go to common waste biomedical waste treatment facility, and these are kind of PPEs, personal protective equipments. We all know how much they have become important since Corona crisis. They have to be used essentially by people who are handling infectious waste: gloves, helmets, breathing apparatus, earmuffs for noise, working in an area with noise, goggles or a face shield or coverall. So all these PPEs need to be used by people who are handling hazardous waste, biomedical waste. These are example of some of the autoclaving facility, incinerator on the right hand side top, and other view of incinerator on the left hand side. How these facilities, when the people working there, operate them in a safe manner. Storage facility for the interim storage when it comes to common biomedical waste treatment facility, how it has to be separately stored, not mixing the different categories together. Burial, as I said, in the rural areas where such kind of infrastructure is not available, and also waste generation is not much in the healthcare treatment facilities in the rural areas. So any anatomical waste which they generate, minor surgery or say delivery happening there, that they can within their premises can bury them into deep pits. And deep pits, the specification is given in the biomedical waste rules. Important feature is that a deep pit should be in such area that it can be securely fenced, which is not accessible to people. And these pits, there are different layer of material put when the pit is filled. Biomedical waste rules followed by soil and lime, followed by soil, until the pit is full. You keep on dumping this waste, and when the pit is full, then you seal it, and then you move to next pit in the same hospital area. Location criteria, the biomedical waste rules also provide location criteria for the waste. And important elements which decide on what should be the location is potential to spread infection from the waste stored in the premises should be minimum. Applicable standards for pollution control can be implemented, and relative efficiency of existing incinerators and emission control system can be accessed and studied time to time. Potential of fugitive dust emission from incinerators needs to be addressed. Potential of discharge of wastewater, odor production needs to be addressed. Potential for noise pollution needs to be addressed. Risk posed to human health safety due to exposure from incinerators, risk of fire, and significant residual impact of the waste. Say, for example, if you are using incinerators, you generate a lot of bottom ash and fly ash, and how is that managed also need to be addressed properly. So I'll skip this because we have the hazardous waste, this also to be covered. Now, quickly, what are the because mercury, as I said, is a special waste which gets generated in the hospital, and special precaution has to be taken for the mercury management in the healthcare facilities. And their guidelines, when I say ESM is environmentally sound management. And what is recommended in environmentally sound management for mercury? Why is mercury dangerous? Because mercury can get released into air in the patient area or into wastewater due to spillage in working environment. Release, if you are kind of incinerating mercury bearing waste, then mercury also gets released in the air from the incinerators. And disposal of mercury waste, for example, mercury dental amalgams, which are frequently used, can also contaminate the soil and water body. So mercury has to be recommended technologies that use alternatives. If best is that you phase out mercury, and there's a convention called Minamata Convention, which Government of India is also signatory now, and with lot of other countries now, Government of India is also working toward phasing out mercury from the healthcare treatment facilities, treatment systems. So now you see a lot of electronic blood pressure monitoring equipments, a lot of electronic thermometers, a lot of other electronic materials where mercury is no longer being used, but still a lot of older equipments and systems have to be addressed. Spill management, addressing spill by collection and amalgamation of mercury. Storage of mercury bearing waste properly and safely so that mercury doesn't get released, and recovery of mercury at the dedicated facility. So these are recommended environmentally sound management technologies for mercury. Now, as the time is less, I'll from biomedical waste move to framework for hazardous waste management, and because around 5 to 10% of healthcare waste facilities also hazardous in nature. And what is the framework for management of hazardous waste? Definition, by definition, hazardous waste is slightly different for biomedical waste, because biomedical waste doesn't include some of these properties. Hazardous waste will essentially mean any waste which, because of its reactive characteristics, toxicity characteristics, flammability, explosive or corrosive characteristics, has potential to cause danger or causes danger to human and health and environment if they are not properly managed. This definition has been brought in by definition of hazardous waste management rule, which also incidentally was notified in 2016, and they have given various broader categories for waste which is generated will be called hazardous waste, and along with the rules, they are schedule 1, 2, and 3. So they mentioned that how each of these kind of waste has to be mentioned as per hazardous waste regulation. Some can be still recycled, some are not to be recycled and recovered, and almost all of them need to be processed and disposed in a secured landfill. So what are the salient features of hazardous waste management rules? Scope of the rules, if you look at earlier notifications, the scope now has been expanded using including other waste. Earlier other waste, what other waste means is say waste tires, the waste which is generated in a huge amount but still are not covered as a hazardous waste. For example, tires which are generated from automobiles, from large vehicles, so they are now included as other waste, and they have to be also dealt with along with hazardous waste. Authorization and registration requirement for hazardous waste management generating industries, and standard operating procedures are prescribed for waste processing facilities which need to be complied by various stakeholders. Waste management hierarchy is emphasized. If you look at waste management hierarchy, what it essentially mentions is that waste, when you are doing a process operations, first preferred option is to avoid waste, to reduce waste. If you cannot avoid waste, cannot reduce waste, then reuse waste or recycle waste, and also if recycle and reuse is not possible, then treat it before disposal. So this is waste hierarchy which is followed in all the waste streams. Interestingly, hazardous waste management rules also has included in this hierarchy a concept of co-processing. What it indicates is if the waste which is generated has certain calorific value and can be safely co-processed in cement kilns, then such waste should be going to cement kiln as a fuel. And co-processing has been given higher priority than incineration and disposal. So just before, after recycling and reuse comes co-processing, and then incineration and disposal. Other salient features of the rule: responsibility of environmentally sound management of waste by state government includes provision of industrial space for waste processing and setting up waste recycling facility. Registered workers who are engaged in waste recycling, waste processing, and provide them skill training under industrial skill training development program. Now, if you look at Schedule 1, there are 38 processes, industrial processes, which are identified as generating hazardous waste. For example, if you're using paint or producing paint or electroplating or petroleum refinery, fertilizer industry. So all these processes, key processes, are generating hazardous waste. And if you are doing such operations, then you're generating hazardous waste. Schedule 2 gives you constituents, waste constituents. For example, if your waste is having mercury, then above certain limit, it will be called hazardous. Below certain limit, it will not be called hazardous. Similarly, lead, cadmium, other organic materials, they have given you a range of concentration limits. Schedule 3, list of import and export is simplified and provided, because what happens is in global economy, a lot of waste like zinc, cadmium, zinc, lead, copper, goes from one country to another for recovery and recycling. So what waste is allowed for import for recycling and what waste is allowed for export from India for material recovery is mentioned in this rule. Import of waste such as metal scrap, electrical and electronic equipment, paper waste intended for reuse and recycling is allowed in the country. But waste which is not allowed to be imported for reuse and recycling are waste edible oil, fats or oils, household waste, critical care medical equipment, tire for direct reuse purpose, solid plastic waste, waste electrical and electronic assembly scrap, and other chemical waste, especially in solvent form, is not allowed for import, because if you import them, then there's a chance that you'll not properly recycle them, you'll take it for dumping after import. Status, if you look at example of some of these hazardous waste streams, acids and alkalis coming from metal finishing operations, cyanide waste again coming from metal finishing and heat treatment operations, metal waste like mercury, lead, cadmium, chromium coming from processes like chloralkali manufacturing, metal plating, tanneries, textiles, asbestos waste coming essentially from construction and insulation material. These were kind of inorganic waste streams. On the organic side, major waste types are halogenated solvents coming from dry cleaning operation, degreasing, de-oiling operations. Non-halogenated solvents coming from use of paints, inks, adhesives, also used in cosmetics. Paint sludge, as the name suggests, painting operations. Oily waste processing and use of mineral oils in industrial applications. PCB stands for polychlorinated biphenyls. So they are the kind of thermic fluids which are used in transformers. Earlier transformers used to have a lot of PCB, these dielectric fluids where PCB was a constituent. Now, of course, we are using dry type of transformers, but still there are older type of transformers which still needs to be managed. So source are dielectric fluids, hydraulic and heat transfer fluids. Biocides waste coming from pesticide or insecticide manufacturing facilities, essentially from manufacture and use of biocides. Generation of hazardous waste, if you see figures of Central Pollution Control Board, around 7.7 million tons is generated every year. And there are around 47,000 facilities generating this 7.7 million tons. Of this, around 3.8 million tons is landfillable, goes to landfills. 0.8 million tons is incinerable and goes for incineration. And 3.1 million tons is recyclable. Most of it goes for recycling, but there's still scope for sending more waste for recycling. On non-hazardous waste side, there's also a huge amount of non-hazardous waste generated from industrial origin. So generation is around 300 million tons per annum, dominated mainly by mine tailings and fly ash, which is generated from thermal power plants. If you look at environmental impact of such waste, this slide gives you, if this waste is not properly disposed, then how it can cause impact to ultimately human beings on the right hand side through various environmental media, by evaporation to atmosphere, inhalation to man, by release into soil, direct contact with aquatic and terrestrial biota, and use of that by contaminated biota by man as a food. So ingestion of food, again man gets affected. From soil dissolving into water and coming to water, man consumes water for drinking. So kind of again through inhalation route, through ingestion route, and through ingestion of food and through direct contact and ingestion of water, how man can be finally affected by impacts of hazardous waste if they are not properly disposed. Similarly, there's also impact on environment if waste is not properly managed. Though this looks a little complicated, but I mean, There's a potential of a waste improperly disposed on groundwater contamination, surface water contamination on your left-hand side. And if the waste is volatile, then it goes up in air as an odor, causing odor problem. Waste also degrades over time, anaerobic degradation, digestion in the waste pile, and a lot of methane gets produced. And methane, as all of you know, is a greenhouse gas. So it has a greenhouse gas emission potential as well. And a lot of these landfill sites, which are not scientifically designed, are actually source of greenhouse gas emission from the waste management sector. So human exposure pathway is essentially through air, inhalation or absorption on skin, through water ingestion, and through soil, again, ingestion. These are some of the slides to kind of familiarize you on what happens if the waste is stored and collected, but not collected and stacked properly. And there's no guessing that this waste is causing contamination of the soil, and subsequently, at some point of time, this will also go down to the groundwater and contaminate the groundwater. Now, what is dangerous here is the surface contamination still can be managed by certain remediation technologies. You can scrap the soil, take it for treatment. Problem comes when the groundwater gets contaminated, and groundwater gets contaminated because if the groundwater gets contaminated, it's very expensive to take out the groundwater and treat it and send it back either to groundwater source or use it after treatment. Unscientific disposal, indiscriminate disposal of waste illegally, sometimes by the roadside. And you can see, I mean, there's no price for guessing that when the rainwater comes, all this waste will get dissolved and drained from the roadside to pollute the soil and groundwater in that area. This is kind of example of how groundwater can be contaminated, and this is a classical example of a dye manufacturing facility in Rajasthan, and how over the years of operation, the sludge which they were generating was not stored properly, and when the rain came, all the sludge got washed away. Around 70 groundwater sources, borewell sources in that area got polluted, and this was the water which was coming out. Subsequently, Government of India took a remediation exercise, and all the 17 groundwater wells were kind of treated, but very expensive. Industrial discharges can also cause a lot of river water contamination, and I mean, those who follow the news around the Bangalore area would know that there's a lake where a lot of surfactants get discharged, and every year it catches fire and also causes pollution. And what it does is, since they are surfactants, they cover the water body, so the sunlight doesn't penetrate. Sunlight doesn't penetrate, so all the photosynthetic or light-related reactions don't happen in water bodies. So those floras and faunas which depend on sunlight don't survive, and subsequently it affects the food chain, affecting the higher organisms as well, and they kind of over the period die out. Disposal of hazardous waste. Unlike municipal solid waste, requires a very sophisticated handling. Though I mean, municipal solid waste also requires a sophisticated handling. If a waste has to be disposed on land, then this is kind of precaution which has to be taken. If you see this is a pit where I mean, a HDP liner is placed at the bottom, and below this HDP liner is actually 3 feet clay, which is put. And once this liner is done, on this liner, then again clay is put just to maintain these liners in place. And on that bottom, then you start disposing your waste. So this is to show you how much care one has to take for disposing hazardous waste in the landfills, so that they don't end up contaminating, they don't end up polluting the soil and groundwater. This is one of the facilities in Ankleshwar, which is secure landfill site, and how this is show you how I mean they dispose waste, and this is kind of one of the dye intermediate industries disposing waste here. And immediately when the waste comes, it is disposed and then kind of spread by these machines, and soil is spread over the waste, and then they are compacted in the truck. I told you some of the waste requires encapsulation. For example, if waste is very infectious or waste is very hazardous, it requires mixing with the cement matrix and stabilizing them and solidifying them, so that after that they can be disposed. Advantage, though cost of processing goes up, but advantage here is that this matrix, cement matrix, doesn't leach the waste when the waste is put in the landfill site. So this is one of the operations on how after every day's disposal of the waste, soil is spread on the landfill at the same landfill, and how it is then compacted with the compactor, so that no waste is exposed to the environment. In monsoon period, what is done, because a lot of rain happens, so waste where you're disposing waste is again covered with HDP liner, and the waste which is coming in the monsoon period is stored in the separate facility till the monsoon is over, and then the waste is brought here and disposal process starts. The landfill also has certain vents because I told you waste degrades when it is disposed in landfill site. They degrade and sometimes generate gases, and these gases need to be vented out from the landfill site. Otherwise, over the period, gas will accumulate and the landfills will explode. Sometimes accidents have happened because proper venting of these gases were not there. So these vents essentially ensure that these gases which are generated time to time are taken out. This is one of the one of the sites, one of the cells of this landfill, which was used earlier for around 15 years and now has been closed. And you see, I mean, how engineeringly, how scientifically it has to be closed, and now the space which is created, the space which is generated, is used as a picnic spot by the people in the vicinity. So this is kind of care one has to take, and this is kind of care one has to exercise while dealing with hazardous waste. I told you that in monsoon period the disposal is not done. So in monsoon period they store the waste in the shed, and till when the monsoon period gets over, then the waste is taken out and disposed. Other than looking at how waste is disposed, one also has to basically constantly monitor the groundwater quality in the area where this landfill site is there, especially because groundwater also flows in a direction, especially downstream direction of the groundwater flow. So this is kind of borewell which is installed for groundwater quality monitoring. This is to ensure that no contamination is observed in the waste disposal. And if any contamination is seen here, then you know that something is wrong, and you need to basically then take the corrective measure in the waste disposal. These is kind of manifest forms which are followed by industries which are generating waste for easy tracking of the waste, so that, I mean, instances of illegal disposal doesn't happen, and the waste which is originating from the industry goes to the common disposal site, not elsewhere. And common waste disposal site then acknowledges that they have received this waste from industry, and they are disposing it properly and report to State Pollution Control Board, so that State Pollution Control Boards can track the hazardous waste which is being generated and which is being disposed. I'll quickly skip this. Waste which is accepted at this particular site, which I showed you as an example. There are quick analysis done every day when the waste comes. The leachate of the waste the pH has to range from 5 to 12. Should be within the 5 to 12 range. The leaching test, PFLT leach test, for moisture content, waste should pass. It should not have more than 10 to 15% moisture. POC should be less than 5%. Ignitability, waste should be non-ignitable, waste should be non-reactive. And physical checks also done time to time. And waste should not have perceptible odor. then the waste is allowed to be disposed at this site. This is the liner criteria, and just to tell you how complex is the lining system. From the bottom, if you start, the allowed distance from groundwater, highest groundwater level is 6 meters, more than 6 meters. So from the landfill to the groundwater, there should be separation of at least 6 meters, followed by compacted subbase with clay, 50%. 1500 mm clay liner with permeability of less than 10 to power minus 7 centimeter per second. Above that, 1.5 mm thick HDPE geomembrane, which I showed you in the photograph. Above that, geotextile, just to retain the membrane in the place, of 200 GSM size. Then above that, 75 mm thick precast with sand bed. Above that, 300 mm leachate collection and drainage collection layer with a drainage of around 10 to more than 10 to power minus 2 centimeter per second. Why high permeability here? Because any liquid which is coming here should not go below, should be drained at the drainage layer itself. And above that, final ceiling geotextile of 2 GSM size. Similarly, similar to bottom, there's also configuration of cover when the landfill is full and you need to close the landfill. Similar specification in the opposite direction you need to follow for the cover composition, and then cover is closed, and then you put all your greenery. When I showed you top of the green closed landfill, and then landfill is closed. So with this, I'll end my presentation here, and I thank you for patient hearing, and we'll be happy to take questions from the participants.
Yeah. Hello. Yeah. So can you hear me?
Yeah, I can hear you.
Yeah. Thank you, sir. It was a really good session. We have a few questions over here, and from a few of our participants and all. So we have just summed up 4 questions out of that. So it's mainly one question was that you said about the incinerators. So we have been using incinerators in Kerala also, in mainly in the cities like Trivandrum and all. Actually, what happened is that using this incinerator, itself was a bit costly because it was using diesel. So could you comment on your vision on this? Because what I thought is that if you are using one sort of method, it may have a more issues which are creating than we are trying to solve. So could you please share your thoughts on that?
See, incinerators are recommended only for the waste types where no other treatment is possible, and also the incinerator should have certain the waste which is going to incinerator should have certain calorific value. So that incinerator is not entirely dependent on, as you said, diesel fuel or any fuel which is powering incinerator. It has to be kind of largely powered by waste calorific value in the waste. And incinerator is recommended only for waste which is very hazardous or very infectious kind. For example, if you look at biomedical waste, just because of its very infectious characteristics, human anatomical waste or animal anatomical waste, they have, if they are not treated properly, they have problem of spreading disease. There, the incinerator is recommended. I agree that incinerator requires very strict operational parameters to be followed in terms of temperature regime, in terms of excess oxygen, in terms of combustion efficiency, and that has to be followed. And that has to be monitored. If they are not followed, if they are not monitored, then incinerator actually can create more pollution than it is treating. So that's a limitation incinerator has, and it's a kind of very costly option for treatment of waste. But for very toxic, very highly toxic and highly infectious waste, incinerator is recommended. Okay.
Yes, sir. Yeah. So, few more questions. You were speaking about the 75-kilometer radius for this disposal facility. Yeah, for the biomedical waste, right?
Yes.
Yeah. As for what I thought is that is it actually implemented all over actually in like the 75-kilometer radius, or is it in proposal mainly?
No, this is now notified by the rules, and this is part of the rules now. Idea is that you don't create many common waste treatment facility in the same area, and
Okay.
then these common waste treatment facilities start competing with each other to get the waste. So idea is,
Okay.
and also,
Okay.
I mean, if for some reason any area generates more waste than capacity of this common waste treatment facility, then obviously
Actually,
other
yeah. From where does the funding come? Actually, is it state funded or central funded? What is the actually strategy of investments for this sort of?
some of it is state funded. Central government
Okay.
also has a scheme, MOFCC, where
Okay.
some fund comes from state, some funds from central government, and some fund the entrepreneur has to put.
Okay. Yeah. And then yeah, encapsulated waste disposal. There was few comments on that. So it was really interesting. What you mentioned was that actually what I got from the is that the waste is being added with cement and it's being made a capsule, right?
Yes.
So is it actually implemented in many parts in India? I haven't heard of it much. So what is the
In,
possibilities that about it?
yeah, in some waste treatment facilities it is practiced. For example, I showed you facility in Ankleshwar, where I mean this solidified uh, waste was being disposed. In waste management terms, the process is called stabilization and solidification. Idea is that when you look at waste constituents, some of these waste constituents, they are more water soluble and they move faster when they are impacted with water. For example, there are some heavy metals which are very notorious. Example, if you look at chromium, chromium is very fast leaching heavy metal and also very toxic. So, and also mercury. Mercury is not only volatile but also very toxic. And also another example is arsenic. If you are generating arsenic bearing waste. So idea here is to basically mix them into, stabilize them into certain solidified matrix using say limestone, using fly ash, using cement. And there's a test which is provided by US EPA. It's called toxicity characteristics leaching procedure. So if your solidified sample passes this test, then you can use this solidified sample for, you can dispose this solidified sample in the landfill. Idea is that nothing should leach out of the solidified waste when the waste is disposed in the land. Is that clear?
Yeah, yeah, thanks. We have many more questions, but now, yes, I would like to inform the participants that the Google form for the attendance has been shared in the WebEx chat. And yeah, I will open the floor to the participants to directly interact with the speakers. If any participants are willing to interact, you could directly interact. I also request you to turn on your videos so that the attendance can be recorded. All the participants, please turn on your videos. Yeah. Okay, okay, thank you all. Okay, thank you, sir. That was an insightful and interesting session. There are many, I'm sure that there are many queries again. So due to timeless, we have the next session scheduled. Okay, thank you, sir. Yeah,
Sure, my
thank you
pleasure.
for all your, yeah,
Yeah,
yeah. Yeah,
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 thank you
we'll
very
have
much.
the next session at, yeah, yes, sir.
Sure.
Yeah. Okay, this is for all the participants. We have the next session at 11:30. We'll have a break till 11:25. You can join by 11:30. Thank you.
Sir, we'll address you directly from the
Yes.
WebEx.
Hello, sir. So can you hear me?
So you'll have to unmute yourself. Can you please unmute yourself? Can you please unmute yourself? There is an option for mute below. Mute, unmute. Yes. Yes, unmute.
Yeah. Okay.
Yeah. Yes, sir. We can hear you.
Yeah. I can listen you.
Can you
Can you
just
listen me?
Yeah. Yeah. Fine, sir. Yeah. Good.
Okay.
I'll cut
Can you
this
just
call,
on
sir.
the video? It is.
Pardon?
Can you please on the video? Your video.
Start the video, no?
Yeah. At the bottom itself.
Cannot connect to the camera.
Okay. Cannot connect to camera. 1 minute, sir.
Hello.
Yeah.
Yes, sir. What was the problem?
I have started the video.
Okay.
Start my video is another option. So on that, it cannot connect to the camera. The comment is cannot connect to the camera.
Okay, sir. Are you on your laptop or on a desktop?
I am on the desktop.
So do you have a webcam on the desktop?
Yeah, it's on.
It's on. Okay. So can you just next to video, can you see a arrow mark? Next to start video, stop video, there's an arrow mark, right? So can you hear me? I think you have. Sir, can you hear me? Hello.
Yeah.
Yeah.
ഇതൊന്ന് mute ചെയ്യ്. ഞാൻ phone
Unmute, yeah. Mute, yeah.
Yes, please. The problem is when I start the video, it says the cannot connect to the camera. Start video is there. Yeah, start video is clicked on. Yeah. Yeah, it comes Lenovo and setting. Yes. Yeah. Yes. It's a Lenovo USB UVC camera. It is selected. Yeah. Yeah. Yesterday it was on. Yeah. Yeah. Okay. So in that case, how to shall I share the PPT? Yeah. Okay. I have not yet selected PPT. Yeah. I have to open the PPT and then share, no? Yeah, okay. Okay. Just a minute. Yeah, the PPT is open now. And then I will go to the browser again. Yeah. Yes. Yes. Yeah. Okay. Now can you see the PPT? Yeah. Yeah. Okay. Yeah. Yeah. Okay. Yeah. More. Yeah. Okay. Yeah. More options. Yes. Yeah. It shows the looking for nearby device. Search for call a video system. Not it. Yes, it's all okay. No problem. No device found. That comes no device found. In the morning it was running. I presented somewhere also my lecture. Not this one. Other. The host has not admitted you to the meeting. You will be disconnected in 52 seconds. That's what it says now. Yeah. 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 Start. So I have to again go for stop video. Okay. Settings. Camera. Camera is there. First option is camera. Yeah. Lenovo. Below that is setting. And then change virtual background. Yeah. No, not it. Just wait. Yeah, now the screen is coming. Now can you see me? Yeah. 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 Now where to go and share, isn't it? Yeah, okay. Okay. Yeah, okay. Yeah. Okay. Yeah, okay. So I will put my phone off. Do you mind for that? Because a lot of phone calls come in between. Yeah. Okay. Yes. Yeah. Okay.
Yes. Yeah. Good morning. I just now invite Architect Leah Loy to introduce the second speaker of the day.
Dr. Nitin Shinde is currently Renewable Energy Private Limited, Heliosol Energy Private Limited, and Senior Renewable Energy Consultant. Initially served for 20 years with Tata as control engineer for India's first 500 megawatt and various thermal power plants. Dr. Shinde is coordinator of Make in India research group activities in the state by participation of institutions, organizations for extending renewable energy research. He is committed for inclusive, sustainable development and an advisor to renewable energy power generation projects, especially solar PV in India and abroad. Many major solar PV power plant consultancy projects are to his credit. He is a visiting faculty of 4MR of Central University, Jaipur, and Shivaji University for Sustainable Architecture and Integrated Energy Technologies in Building. We welcome you, sir, to the day 8 of FDP. Over to you, sir.
Yes. Hello, sir. Can you hear me?
Yeah, I can hear you.
Yeah. Sir, you can start the presentations.
Yeah. So shall we start?
Yes, sir. Sure.
Yeah. Okay. Yeah. Good morning to everybody. Can you listen me?
Yeah. Yes, sir. Sure. Can you make it full screen? There's an
Yes.
option near that volume control.
Yes.
Yeah. Can you please press that? Near that
The
minus sign. Volume control. The right down. The right side bottom. Near that minus sign. Yeah. No, just left to that.
no,
No, sir.
it should
Just
be
left to that icon.
there is a continuity in the left hand side bar.
Okay. Okay. Yeah. Fine. Fine,
Yeah.
sir.
Okay. Yeah. So today we have a very interesting subject. The subject chosen is also very appropriate with the current time. The subject is the technologies for sustainable development for mitigating climate change in building construction industry. The addition that the climate change mitigations in building construction industry is chosen because mainly the audience is from the architecture side, the civil construction. And since the sustainable development is very important as far as the national policies are concerned, So we have chosen this subject to introduce technologies in building constructions for climate change mitigations for the national sustainable development. So if you see the issues regarding the subject, mainly there are four topics which are incorporated in the subject. One is sustainable development, another is the climate change mitigation, and these both are connected to the building construction industries, especially the sustainable architecture subject. And now we are introducing the technologies to achieve the climate change mitigations and the sustainable development. So what should be the role of an architect towards the climate change mitigations and sustainable development for the national policy is very, very important. And this sustainable architecture is attracting a lot of scope in the future. It has to be related to the especially the technologies which will lead to the climate change mitigation, which will finally lead to the sustainable development. So these technologies are renewable energy technologies, which will help reduce the carbon footprints and improve the sustainability. The technologies are very important. That's why generally what happens now, the architect role is to arrange the technologies. So he should be aware of what sort of technologies that can be used in the future, which are renewable, which can be used again and again, and should help the climate change mitigation. That's our target. So to understand what exactly the sustainability means, it has been defined very properly so far. So see how it looks like. Sustainability has often been defined as how biological systems endure and remain diverse and productive on the earth. So these words are very, very, very important. See, there should be sustainability for biological systems wherein we are concerned. And our ecosystem should be maintained. That's our the biological system endurance. And the productivity on the earth has to be improved because the productive is concerned with the development. If we can clearly define further, which is applicable for the 21st century, that sustainability refers to the need to develop a sustainable model wherein we all architects are concerned. And these models are necessary for both the human race and the planet Earth to survive. So we can survive only if the planet Earth survives. So what should be our objectives in maintaining the sustainability? The sustainable development should meet the needs of the present without compromising the well-being of the future generation. And the future generation is nothing but what we are important, which will again develop our nation. To achieve this sustainability, the human will have to re-examine the policies on environmental protection, social responsibilities, and economic practices. See, all this environment, the social, the economics are related to the development. An architect in building industry is also concerned with all these aspects because they are our very close neighborhoods in future. See, any society or many individuals form the society, and we live in a proper environment. And our target is to achieve the economy and the development. If these three are interacted, and how remotely this sustainability is possible is understood in this figure, that the three circles interactions which leads to sustainability. See, everyone, social means our society, and we individuals live in a society. And we have to, the society is covered with the environment, which should be protected. If we see the social and an environment, it should be variable to the both to the individual and the environment, both should be variable. All these practices today that we are facing, the difficulties in regarding the environment is only because it is not whatever man-made constructions and other things are not variable to the environment. Similarly, when an individual living in a society want to make the developments, So individual has to be equitable for the national development. And again, this social development should not impact the environment. This is what the sustainability means. And there is a remote chances of achieving sustainability for where all the circles are interacting at the center to achieve the variableness, equitableness, and the viability between the environment and the economics is very, very important. We will see how these things lead in a particular way to the development. So let us understand what the development is. And we want a sustainable development. The development is a process by which an economical well-being and the quality of the life of a nation, region, local community, or an individual are improved according to the targeted goals and the objectives. So if to understand better way, so how much we develop. So GDP is a measure for that. So this GDP, which is a measure for the development, affects the well-beingness and the quality of the life. So if we consider that development is a process of, and it is a growth, the output of this scenario is to increase the productivity. And the outcome of this scenario is to improve the quality of the life. So if we want to develop, we should increase our productivity and we should have a good quality of the life. So the figure below that diagram is a process. This is a development process. So this process, what it indicates is there are inputs and there are the outputs. And all the outcome is nothing but the quality of the life. So we should able to concentrate on this development to give the quality of the life in a long future for the future generations, we can say. In this process, there is the input of raw material which comes from the natural resources. There is the input from energy, and the output is the products and the services, which is the measure of the GDP again. And what remains is the waste that leads to the pollution. So, if we understand this process properly, we can lead towards the sustainability considering all these parameters of inputs and outputs. So see, if we want the increase in productivity and if we want the quality of life, there has to be development for the human being. So as far as development is concerned, we need a development. There is no option. We should grow. We should increase the quality of the life and the productivity. Now, how to do it? Keeping into mind all the time, there should be a growth. If we see again, we are related to the three circles, which is sustainable development. Now, from sustainability, we have properly defined to a sustainable development. And we need a sustainable development. We need the development. So, if we see the process of development, that is the inputs and the outputs. So, this is nothing but the human creation of good economy, therefore, should restrict to the design, construction, and the industrial production can stay inside the process. See, these are the industrial products, and there is a process. So, how these two are related, or how these two should be related, is using totally innocuous, more pleasant, and more efficient materials, which are the natural, and producing the goods without generating residuals. We do not want any residuals. Now, how to arrange this is very important. See, if we see the three circles, there should be an interaction between the social, environment, and the economic, and we all should be the variable, viable, and the equitable, which leads to sustainable development. So, what we have learned, living an individual in an environment, achieving an economy, our target should be the humanity and the nature should coexist. Unless and otherwise, there is no development, there is no sustainable development. So, humanity and the nature coexist is very, very important. Again, see, the human design must interact with the natural world. So, you are the architect, you are the designer, you are the planner, and your building should interact with the natural world, which will lead to the comfort. See, again, trust the natural flows of energy. All are natural flows of energy in a process. So, the format, the communication between environment, the society, and the economy are very, very important. It is the same format between the interaction between this circle, which will lead to a sustainable development. Sustainable development there should meet the needs of the present without compromising the well-being of the future generation, that is the human race, which also includes the biodiversity which present on the earth. So the development what we want is a sustainable development, and we should not harm the environment which surrounds to us, an individual and a society and the nation. And we should grow to achieve an economic. So there should be an interaction to achieve a sustainable development. And we need a sustainable development. We need development, and in future we need a sustainable development. That is very important. Now, if we see again the climate change mitigation process, the earlier what we are looking at the four factors is the sustainable development. We have understood what exactly the sustainable development, wherein the social, environmental, and the economic should be interacted in a proper way. Now, the next is the climate change. So, how the climate change is affecting is very important. The climate change mitigation is important. So first we will see climate change, and then we will see how it can be mitigated. So is there a climate change really? That's very important. If we see the process of economical development, our interaction is between the materials, that the natural sources, energies, and our productivity, which is again a GDP economy, and there should not be the waste. But in this process, what has happened practically for the development of an economy through the industrial processes is nothing but again there is the same energy input, there is the same raw material input, there is the same the products outside, but simultaneously we are generating during the process the emission and the emission from the combustion and lot of things, direct, indirect, energy waste, solid, liquid waste, and so many things are there. So it's very important to see how it looks like the waste. And this waste exactly generate the greenhouse gases. So if we see the effect of the greenhouse gases, it's very, very, very impactful. See what type of the development was earlier and what type of development is as on date. So this is the difference, the previous one and at present. So during the process of the development, we are hampered the environment. We have hampered the environment. It is a man-made. We have developed the greenhouse gases, which is very, very bad to the human beings. So it affects the change in a climate has an effect and it has an impact. It's very bad impact actually. So is there any climate change? Yes, the answer is looking at the last the photo, there is an effect and it's very bad effect. So see exactly how these have been affected to the human race and how this has been impacted to the human race. We are just understanding the climate change. If you see that how the climate change is happening because of the global warming. The global warming temperature is rising, rising, and rising. There is a ozone layer depletion. There is a global warming. There is a loss of biodiversity. So there are the volcano eruptions. There is the pollutions at large. The famines everywhere. The urbanization has been affected. The agriculture has been affected, and the biodiversity has been affected. There is the rise in the sea levels. There is the cyclones. A lot of things are there. So the climate change has affected, and the effects of the climate change are very bad. So if we see that exactly what type of the impact on the human race and the human earth is something like see here, these are the impacts. These are very bad impacts. If one can understand this, the present scenario, where with a zero point 0.8 degrees rise in the temperature of the earth, the 0.8 degrees, which is the present effect, and it is predicted to rise another 2 degrees, 2 to 4 degrees, and how this 2 to 4 degrees will impact on the human being will also we can understand. So with an existing 0.8 degrees effect, see there are heat waves. We are experiencing now also in our nation there are heat waves. There is the ocean warming. There is the effect on the biodiversity within the water. Then the Arctic ice cap melting. The news are there are always news in the media that how this has been affected. The present one which has the glaciers were melting and in Uttarakhand how it has been affected to our the society. It's unknown. So we are experiencing this thing. The sea level rising is also there. So increased earthquake, yes, we are increasing the experiencing earth, the earth waves. Extreme weather events are happening. There are cyclones, there are unpredicted rains, the spacing, the extinction, there is an effect on the food production, and everything is there which we are experiencing. The present age of people, we are experiencing all these things. We are lucky and we are unlucky also because we are experiencing in the present time. We are lucky that we are understanding what type of disasters can happen because of the temperature rise, because of the change in the climate. So this is how it looks like. It now the predictions, the model, the environmental model predicted that there can be a rise in 1 degree centigrade, which also affects a lot. So 0.8 degrees, which is causing the disasters everywhere, what will happen to the 1 degree rise? So the existing, the species extinction, the rare species extinction will vanish. Then the coral reefs destroyed. Then there is the island and the nations will go underwater. So this will is the next effect of a 1 degree centigrade, which will again be, I don't know whether the human race will be sufficient to the bear it. Again, this 2 degrees centigrade, 3 degrees centigrade, again it's very bad. Even the 2 degrees centigrade, which has also been predicted in a few years, which will again have there will no water supplies. Water supplies will affect, the polar bears will extinct totally. There won't be any green lands. It will be melted again. There will be no snow. The amazing collapses and the fires everywhere. The food shortages, the environmental refugees will start. This is what a 2 degrees and a 3 degrees the impact will be. We cannot just imagine for 4 degrees, 5 degrees, 6 degrees, and the other things. The global warming has worsened everywhere, and these are the effects of the partially effect which we are experiencing through and the understanding through the media and other things is very horrible. They are disastrous. It is a catastrophic disasters. It should be mitigated. So climate change is there. We are experiencing all these things. The impact also we are experiencing, which proves that there is a climate change, and without mitigating the climate change, it's very difficult to survive. This is what the conclusion is. So, what is the impact actually, the physical impact of climate change? So, there will be the impact on the ecosystems, where the biodiversity and the carbon storage and habitats, everything will be impacted. There will be impact on the human systems, which include agriculture, freshwater, health. The health problems have started. The recent COVID is also the backbone of it is again the pollution and the unhealthy the practices developed by the human system. Urban systems have been affected. Economic systems have been affected because we need the development which should not affect the day-to-day practices. The social systems have affected because there is an interaction of the three circles, that is social, economic, and the ecosystems. That is environment. That is very important. So the climate change has happened, and our aim should be to target exactly how to mitigate the climate change. So there are a lot of agencies involved, national and international level, especially the United Nations Framework for Conventions of the Climate Change is taking the major role over the global. The majors are taking. All the nations are been incorporated. If you are ratified, if you are signed the contract with the UNFCCC system. So what is that target of mitigating the climate change? See, the climate change under the Paris Protocol under Article 2 says that the pollution has to be reduced, the greenhouse gases has to be reduced, but up to what level? To achieve stabilize of the greenhouse gases concentrations in the atmosphere at a level that would prevent the dangerous anthropogenic interface with the climate system. So this is what Article 2 is targeted. And furthermore, to be precise, they have also targeted that it should not go above 2 degrees centigrade. We have seen the impact of disasters of the 2 degrees centigrade. We do not want to go to the 2 degrees centigrade, but it should be maintained below 1, whatever it is, and go below again 0.8 effect. So that is what this is what has been it is targeted. So 0.2 degrees, the 2 degrees is very far, and we have to limit ourselves within 1.5 degrees as per the Article 2. And this framework is sufficient to allow ecosystems to adapt naturally to the climate change, ensure that the food production is not threatened, and enable economic development to proceed in a sustainable manner. So this is what a sustainable manner, sustainable the development we need, and it should be mitigating the climate change. So this is very important. The subject that climate change is there, we have to mitigate it. There is no alternative, and there are the national and the international practices to control it, to mitigate the climate change. There are ways, and one should do it. We go back again. Role of energy development and conceptual linkage. See, this is what we have added one slide to understand exactly the technologies, how they are related to the environment and how they are related to the development. We need a development to grow. Yes, we need a development. We need a sustainable development. And in that case, if we want to develop, we have to have a productivity to increase. So, so this is the simple process. And again, this is the productivity, and this is the energy. Raw material is natural, and there is a waste. And our aim is to control the waste and the pollution. Now, what the role of energy is in case of a development? If it is a y is a productivity, it is a function of a k, which is a constant, h is a human factor, and E is an energy. Again, this energy is nothing but unless and otherwise we do the human development, that is the improvement in the lifestyle. The energy development is not there because it is a process. And H, which is a human development, is a factor with the time. If we have an energy, we can develop the human development. And if we have both energy and the human development, we can increase the productivity. So this is what it is the related to the development. If we want to have the productivity to increase, we have to increase the input, proportional input of the energy. So Y is directly proportional to the energy, and the human development can proceed with the due time to improve it. So this is what a role of energy is in the sustainable development. So development, the part is the human skills and also the energy inputs. So aim to utilize the less resources and produce the no waste. So when energy is related to the productivity, our aim is to minimize the raw material uses and minimize the waste, that is the pollution, which will mitigate the climate change. The climate change mitigation strategies for that to have a minimum the pollution and the waste is to, again, it is the renewable energy in addition of renewable energy in energy mix, improvement of energy efficiency in transport and construction, then the sectorial measures which are related again with energy and the productivity of agriculture, fisheries, industry, water, ecosystems, health, etc. Then those are the sectoral measurements, and the market instrument, that is the change in policy, its effects, the transitions considering the sustainability. So these four are the strategies to mitigate the climate change. So if you see that everywhere in all these four strategies, energy is very important, and that's why this energy is related to the productivity and the sustainable development. To integrate the adaptations of the climate change in an economical system is also to be targeted, and then the strategy for mitigating the climate change. So integrate the adaptations of climate change in a market instrument like the change in policies, etc., is also the part of the strategies for mitigating climate change. And the forms of energy plays a major role, which is again indicated in renewable energies and energy efficiencies. All these are the technologies. It's very important. So now importance of construction industry. Now we have seen the sustainable development, why it is important and how to mitigate the climate change. Now how both are related to the building industry. That's very important. Construction plays a role exactly the major roles in economy. It says that the construction contributes to economic development by satisfying some of the basic objectives of the development, including the output generation, employment creation, and the income generation, the redistributions, and so on. So construction is very important and it plays a major role in economic development, and the development should be the sustainable development. It also plays a major role in satisfying the basic physics and the social needs, including the production, the shelter, the infrastructure, the consumer goods, and has an influence on the human development in the national social economic objectives. So that's how we look at the construction. Construction industry is very important. That's why an architect related to the construction industry should have always in mind to go for the sustainability and go for mitigating the climate change. The goal of sustainable development, again, a construction and a sustainable development, is to enable all the people to satisfy their basic needs and enjoy a better quality of the life without compromising the quality of the life, the future generation, building construction serve the purpose of being a sustainable. So our building construction, if we want to go for sustainable development, our building construction has to serve the sustainability. And it's the purpose of being a sustainable is very important. Introducing sustainability in a building. Buildings that are designed, build, renovate, operate, and decommission in an ecological and a resource efficient manner is very important. So this will protect the occupant's health, improve the employee productivity, use of energy, water very resourcefully, and other resources very efficiently. It should reduce overall the impact on the environment. So this is what a role of a construction in an economy and a role of an architecture in building construction, looking at or considering at a sustainability. So this is sustainable development. So architect has to consider the environmental aspect, the individual aspect, social aspects, and economical aspects as far as the construction industry is concerned. So it's important. That's why we have chosen a construction industry. Looking at the role, that is the technology environment in a sustainable building. The construction has to be sustainable. So if you want to build the building, so your building has to be sustainable. Then only we can understand its total effect. So what was earlier and what was sustainable building proposed? When an earlier conventional building design and the operations during the life cycle of the building, it include the fossil fuels. Then we have considered the light level, air conditioning, air handling system, the furniture and exotic materials, and the consumers like raw materials. So again, when it is processed during the construction, it has led to the carbon dioxide emission and waste to the landfill. In a conventional building, it is happening. So what a new sustainable building, the design and operation should be to achieve the building to be sustainable is the use of renewable energies instead of the fossil fuels. The sustainability has to be considered. The locally resourced material has to be used. Again, the passive cooling, lighting techniques and the technologies has to be adopted. Regular maintenance program through the simulations has to be adopted. Adaptations of way working and the recycle and the reuse has to be used. This is what it generally is called the green buildings. So this effect of the output again is minimizing waste and recycling infrastructure resources and reduce the carbon dioxide emission. So this is what exactly we need. We need to mitigate the climate change, and reducing the carbon footprint will definitely will lead to the sustainability and mitigating the climate change. That's why how to give the inputs of all these resources in a proper way to mitigate the climate change and to achieve the sustainable development, because building is a part of the major development economy. So this is what exactly the sustainability is related to the building construction. And now we have to look at all the inputs parameters. Input parameters, again, they are very important, because if we see the process, basically the input parameters are important with an additional the concept of zero energy. So the zero energy building means nothing but reduce your the resources efficiently, go for energy conservation, achieve a minimum level of the consumption of the energy and the technologies in a passive way, and target it that whatever it is where come minimum needed for a particular building industry, the energy has to be developed, has to be generated from the forms of the building and the within the building. So the zero energy means zero carbon, and the achieving the zero carbon in case of industry has to be targeted by the planner and the architecture. So how exactly it works? The project is designed to use only the energy from renewable energy sources generated on the site. This renewable energy sources at site is very important. So now we have to see exactly how these renewable energy technologies can be integrated into the building to lead this. Now the building has to be energy efficient. So energy efficient house face south to take the advantages of solar gain. They are the triple glaze. So it's there are many ways, not exactly the glazing, but the reflecting surfaces, the facades and the other the chassis, etc. has to be planned in a proper way, whether it's a roadside, offside, the temperature range, all, whether it's a water body availability, etc., has to be considered for the building design parameters. That is the climatic parameters. Then water efficiency has to be achieved. The rainwater harvesting has to be done. So we are maintaining the maximum the natural resources in the building. And again, very important is the in building envelope, which is separated by again the environment and the atmosphere inside. The atmosphere inside has to be a comfort level, and outside the climate is not controllable because it changes from the morning to evening, again the day wise, again the season wise, and the whole year. Every at instantaneous time, the climate is changing, and our target is to achieve and comfort inside the building. So our building envelope plays a major role. So we use some materials for the building, and these materials has to be selected from a renewable or a recycled source around the site. Waste recycling has to be done. Then the refuse collection and the facilities has to be designed in a proper recycling way so as to achieve the least embodied energies for the building materials. So this will lead to something, it is what it is targeted for the zero energy and the zero emission. We do not want any climate change. We want to mitigate the climate, and we have to practice all this, the concepts like zero energy, net zero energy, and so on. So what we have understood so far is the technologies which are required, then the energy conservation, energy efficiency, how to do it by way of energy management and auditing and monitoring and targeting, etc. And this we have looked only into to achieve the comfort in the space conditioning, whether required or not required, depending upon the utility. And it has to be at the least cost and the least energy, which leads to sustainability. There should not be any effect on the environment, whatever will be to the development of the building. So this is what the energy conscious architecture and sustainable architecture we look for the sustainable development. If we look at the building and what there are many parameters, inputs and the outputs again, and the role of the architectural is to have the consideration of the forms of the building, the context, considering the microclimate and the biological the factors around the the transport network, utilities, network, etc. is studying already, but all this again converted to achieve the comfort. See, now when we construct the building, we need to simulate the parameters and we have to check the performance before building construction. So the performance has to be that your building should satisfy uh, the comfort inside for the maximum period of a year. So then we can say that a particular building achieves the target of the comfort and the performance is achieved. That is the thermal performance. So very important is the part regarding the sustainability when we see the economic system, which is again the building is a part of the economic system. There are energy and the materials and they are recycled. The important if we see on this earth the biosphere, then only the solar energy and low grade thermal energy, which again leads to renewable energy technologies. So this is a sustainable system we want to develop, and wherein when we want to put as a part of the input the energy part, then it has to be solar energy, it has to be renewable energy, and this is how the cycle and the three circles interaction is. An individual, the social, the society, the environment, and the economic growth, they are all interrelated in the system. Now, how to target it? Now we have seen that the renewable energy is very important. The the energy conscious, the house or the building is very important, and we need to go for the concept of net zero or zero energy. And along with the methodologies that we are adopting is integration of the renewable energy, that is an RE. So the resources, energy demand has to be checked for the building. Again, the energy efficiency has to be worked out in a building, and the clean supply of energy, which is targeted at the apex of a triangle, is very, very important, which is related to the renewable energy. If we look at the normal construction building, how it can be integrated. So there is the roof, and we need a comfort inside with the roof that requires an insulation. The climate outside is changing all the time, and the space inside a building has to be the condition, or it should develop all the time the comfort inside to increase the productivity. That is the development again. So there is the typical house with the energy conscious building design. So the one has to use an photovoltaic system, the thermal systems, that is hot water, the solar hot water requirement, the solar photovoltaic requirement, and how they are integrated in the building. There has to be some space to keep the inverter. The energy efficiency is related to again the practices, behavior, and also the has to be at the which should have a the star rating, etc. There should not be any wastage so that the heat pump applications can be done. So the energy has to be all the energy input has to be consciously used. So glazed windows, low energy, and the thermal breakage like the passages in between the sun spaces has to be arranged. The passive methodology for the building has to be incorporated. There are many ways. The light we want it should be the task lighting adaptability has to be there. So there are many ways how and energy technologies can be integrated for sustainable building construction. So it's very important. The sustainability in all the sectors. If we look conceptually, so this is what a sustainable design is, and the social means an individual who requires the shelter, and it's an architect role to study the climate, to study the building needs, and study the people behavior, the neighborhood, etc. And he should be able to give the promise for the performance analyzer. So when we try to construct a building, we should be able to guarantee that this building in this climatic zone is behaving over the year to give the comfort inside for the people. Now, this is the target, and that's why the sustainability is very important. The sustainable design is a philosophy of designing physical objects. These are many objects are there. The built-in environment inside, the built environment and the services to comply the principles of social, economic, and the ecological sustainability. So, a sustainable design should look into the behavior between the social and the environment to protect the environment, the development part, comfort, productivity. So all this has to be in a proper way to achieve a sustainability at the center. So the task is difficult and task is major. So some sort of methodology has to be adopted for integrating the energies for the sustainable design. We have some the practices, sustainable architecture, sustainable building for sustainable living. The sustainable living is another category who takes care for sustainability. And this includes that ECBC, energy conservation building codes, energy conservation, energy efficiency, energy management, and the proper way of the energy analysis, etc., has to be done by auditing. The passiveness has to be increased, and the simulation practices through the software, etc., have to be adopted. So when we do this, all these are the technologies, and we should also be uh, incorporate the net zero energy building concept along with integrating renewable energy, and we should be able to check the performance. The building should lead to the comfort, and this comfort, maintaining the environment, it is again we have to check the sustainability, evaluate the rating certification later. There are ways and the means for checking the sustainability by evaluating through the rating of the building or the certification process. It is available. So now the technologies are available to again we can say to achieve the sustainability in the building. So the architecture's role is to integrate the renewable energy technologies into the building. So what are the renewable energy technologies? Because these technologies only lead to the sustainability and the sustainable development, and it will lead to the climate change mitigation. So we have to take care. The change, the climate change, and the impact and the effects of the climate change we are experiencing, they are very bad. So it is very important to concentrate on the technologies which are renewable energy, especially renewable energy technologies. So we can see that whatever comes from the solar, see, the input is the solar energy to the earth. And if we see that if it is the solar, then the wind is the effect of the solar energy. Solar photovoltaic is again the water resources and the energy development. Geothermal energy is also the part of it. The food production, etc., biogas, biomass, everything is depending on a solar. That's why this renewable and all the technologies are sometimes called the solar energies or the renewable energies. All depend upon the solar. So what are these technologies and how they can be integrated into the building? So each of the type of the renewable energy technologies have in detail some design practices, but we will see exactly how they are integrated and what they are called for. Now, this is not the time exactly wherein we are going into the details of integrating energy technology, designing it for a particular building, because all the building located in a particular, we can say, the climatic zone have the different technologies and the different practices of designing. The climate, the temperature, the humidity, the wind, etc., the water bodies, they are differ at every locations, and depending upon that climate, the weather, the practices are different for integrating the renewable technology. We are now only looking at the introducing the technologies. So the first part for introducing the energy technologies is a solar PV in the building. So this is called the building integrated photovoltaic. So there are many buildings in India, also in all the localities in India and abroad also, where a solar photovoltaic is integrated for energy generation. Now, for example, we will give one example that in a house, for example, it has a load of say 10, 20 kilowatt. So one has to study the energy requirements of a particular building and check whether the capacity of a particular PV system is. The PV system has the different components. Again, the photovoltaic, the inverter, the cabling part, etc., everything, which leads to the clean energy development. It has again be integrated for a continuous supply of energies. It has to be integrated with the existing systems like the distribution agency, utility, which are supplying the energies, to the building. So now the factor important is we can integrate solar photovoltaic very efficiently, very economically than what we are buying from the utilities at present. So this PV technology is becoming very, very popular nowadays. The national policy is supporting the integration of the PV technology into the building. And the PV technology alone can lead to the zero energy building, because if we are not using any utility coal-based energy and only using the solar energies, so we have achieved that zero carbon level. The cost economics is also now the viable for integrating the solar PV technology into the building. So the next part is again the solar thermal. At present, we are using the solar thermal, which is the sun's energy. Concentrated solars are there. Then there are different types of solar operating systems, the solar cooker systems, concentrators, and the plate heat exchangers are available. And these water heating systems we are using can be integrated to a typical building. So it has the insulated tank. It can be passive or the active, and this solar thermal energies can be integrated to the building. So our purpose is to, at a particular location and geographical condition, that the sun varies from morning to evening, and it is the angle at which the equator sun makes, whether it's a south part, southern part, or the northern part, depending on the typical the design process for integrating the solar thermal, whether it's a solar water heater, whether it's a solar air heating system, whether it's a space heating or the space cooling. Everything is very important when solar thermal considerations are uh, uh, meant for the building industry. So this is a part of a technology. The next part is the geothermal, which is again treated as a renewable energy. So especially when whether it's a cooling or whether it's a heating. So there are two cycles, heating cycle and the cooling cycle. So there are the blowers and the heat pumps are also available for the geothermal energy. If you see that through the climate data, the supply agencies, all the time they mention where is ambient temperature and there is a ground temperature. They mention only the ground temperature and the ambient temperature only because the area where you want to construct the building, how to lead to the comfort inside the space, that is the space conditioning effect, how it can be arranged. So if your house is in a hot zone, you can the design a cooling system because the earth is cold, so you can circulate the media of heat exchanger to suit whether it should be used for heating or the cooling. If it is a cold country, compared to the atmospheric ambient temperatures and the atmospheric temperatures, the earth temperature is more. So it can be again this the higher temperature can be used through the heat exchanger to make the heat your house or the building hot. So the geothermal energy can also be used for the heating of the cooling systems. Then there is the part of the wind energy. So wind is again the generated because of the temperature difference across the globe. It has a typical the movement over the year, and if we see at a particular location the wind roll diagram, it gives a clear understanding how the wind can be utilized for the building. So generally, whether the wind flows over a water body which cools the building is very important. Where the cooling is important, where the heating is important, then one has to face whether the sun is maximum toward the south side and etc. But the difference in the temperature globally it creates the wind, and wind is being a mass of an air. When it moves, it possesses the kinetic energy, and when it flows over the blade properly designed in a typical direction, it generates an electrical energy. So one has to see exactly around your building what type of the solar the wind patterns are, and they can the wind turbines can be designed in a proper way, whether it's actually the vertical axis or the horizontal axis, which suits the typical wind speeds, is very important. So wind energies can also be integrated into the buildings to generate the energies which also develops a zero carbon. So our aim is to mitigate the climate change. So we have again the waste to energy. Then the biogas, the biofuels, etc. Those technologies are available now to integrate into the building. So the biogas we can directly use for cooking purpose. It can run a diesel generating set and generates the electricity which can be again utilized in the building. And waste which is just a waste and it's harming our environment can also be treated in a proper way through the briquetting and the gasification process, which again runs a generator and it's develop the electricity. So this is again an waste to energy is a renewable energy. We are using the natural resources converting into the waste. And if we see the process of the development, again the raw material, then the energies and the productivity and the minimum waste is our target. So even though we are generating some sorts of waste because of our behavior and the needs, whatever it is waste can be converted into the source of energy which can be recycled. That's what it is, a renewable energy. That's what it is very important. So concludingly, what we can say that we can integrate renewable energy technologies for achieving sustainable building for better living, which will lead to the climate change mitigation and the national sustainable development. We can see through the various technologies that the climate change mitigation is possible, but sustainable development is a challenging task for everybody, for the individual, for the social, again, the national, the globally, it is sustainable development is really a challenge. And the technologies can help this the sustainable development. The challenges can be partly met at present, and that's very important. So the typical subject that what we have taken for consideration for today, that the technology for the sustainable development for mitigating climate change in the building construction industry is partly, I can say, understood. But there are many details actually one has to go into it. One has to practice. I can say that whenever it was, whether we were connected to the academic institutions or whether we are connected to the companies now at present, our aim is to mitigate the climate change. That's very important. So I hope that the subject is understood properly. The practice is required and integrating the technologies into the building for sustainable development. It is only the role of architect. Nobody can do into the building. As a national policy, yes, somebody can develop the policy. But as far as the building is concerned, it is only an architect who can plan and who can implement these methodologies to achieve the better comfort, better performance of the building, etc., to achieve the climate change mitigations. So with this, I think the session I can conclude that this is possible and we should practice more and more in our day-to-day life. So thank you very much for giving an opportunity. I should thank you to the institutions and the AICTE for giving the opportunity. We are practicing this, and if somebody has the typical requirements, I can definitely we can be of the help for integrating into the buildings. So thank you very much.
Okay, thank you, sir, for that interesting session. We have a lot of questions coming up. So before that, I would like to inform the participants that the Google form for attendance has been shared in the WebEx chat. I also request you to turn on your videos on so that the attendance can be recorded. All participants, please turn on your videos.
Okay.
Sir, can you stop sharing your presentation?
Yeah, okay, fine.
Yeah,
Fine.
yeah. We'll have the question sessions now.
Yeah.
A few seconds.
Any questions?
Yes. Okay, sir. Yeah. So your share is still on. Can you just stop sharing?
Yeah, okay.
Yeah. Fine, sir. Yes. So I have a few questions which we got from the chat box actually. So we have actually summed up some of the questions, and in between, if the participants want to ask questions directly, they can ask.
Yeah, welcome.
Yeah, these are many questions from the chat box actually. Just summed up. Yeah. So the first question, it's mainly what we found out that the presentation was more of general, and then towards the end it was specific at few points. So one of the question is that the all our development is directly connected to the GDP and all those the economical development. So most of the construction industry and all are very much linked. So for example, if you take a city like Delhi, a city where there's a lot of development, constructions going on, it's the development of Delhi is mainly related to many other neighboring states. Most of the electricity, water, everything is coming from the other states. The most of the dams which is being built in Himachal and many other neighboring states is mainly catering to Delhi primarily, more than the people of their own state. So how do you comment on those aspects? Like we want development, which is actually a huge sort of development in certain portions, which is centralized in certain portions. And when one state is developing, the other states are a bit of suffering due to those developments. So what is your comment on those aspects?
Yeah, the comment on this is the measure of the policies. The metropolitan, the corporation, etc., have a policy like implementing ECBC, that is Energy Conservation Building Codes. These energy conservation building codes are considered in the background, considering the thermal simulations for the typical area. So that is, we can say that the geographical conditions and also the climatic the zones that we have developed over the India. So if we say that typically the Delhi or that particular climate, so there is a ECBC already implemented through the government agency. So all the development which are related has been an architect there, the planner is there. So he has to understand what typically the ECBCs are implemented. Now, in a recent, the Bureau of Energy Efficiency has been, they have developed that Energy Conservation Act. So, in the Energy Conservation Act, also the basic beneficiary that the people are the stakeholders. Each of the case where it is being developed has to be open to the stakeholders and their comments. The comments can be in the background with the technology, economy, and the environment. So if you see in the foreign countries and the metro cities, every case, every building is exposed to for the comments. So these practices are not being implemented in our region, in India. Now let us start with that practices and see the benefits of the basic stakeholders where the development is going on. Each the beneficiary should react to these ECBCs and other things so that it can be maintained well. So this is what I think. My comment is we should follow the policies, ECBCs, and the stakeholders should be involved into it. And the policy has to be created to include the stakeholders, which is not there at present.
Yeah, thanks. Yeah. Hello. Yeah. Anyone having questions? Yeah, I will go further. Yeah. So actually now we have a lot of products which have a lot of ratings, like ACs are coming 3-star rating, 4-star ratings, and many ratings are coming up. And for the vehicles also, there are many new policies all applicable, and energy efficient vehicles are coming up. So for an example, if we have an AC which is already working for 10 or 12 years, and now there are ACs available for these 4-star ratings, 5-star ratings, and all. So what is your take on those aspects? Should I buy a new AC which has 4-star rating, or should I keep my AC which I already have? Just because it's all going to be e-waste. If I am buying a new product, the last product which I already have for 10 or 12 years is going to e-waste. So how do we, as a common person, how do I take those aspects? What is your comment on those issues?
All the products, especially this renewable energy product. So there is a standardization made by the Ministry of New and Renewable Energy, which is the MNRE. So MNRE has a benchmark products and the specifications. One should assess the website of MNRE and see the specifications which are standard, very standard, and they are very good also. So considering all the specifications worldwide, the present products in the market, they have made a mandatory few specifications. One should follow and one should make the suppliers follow these specifications. That will exactly give you the good products in the long term, which prove the reliability and the adaptability of the product. In Bureau of Energy Efficiency also there is a benchmarking. The benchmark products are there, specifications there. For example, if you go for the refrigerator, etc., so there is the star rating. The star rating is available for the many products. So one used to has to see and check whether the stars are there, whether it's a 1 star, 2 stars, or 3 star. The more the stars, it's the better the product. So it leads to the minimum energy consumption all the way, and there is a saving over the year as far as the stars are concerned. So look into the specifications of the Bureau of Energy Efficiency and also the Ministry of New and Renewable Energy for these renewable energy products and all the products which who consume the energies.
Okay, yeah. So one more question. Actually, now we had this last year to this March 21st. We have the whole year of Corona and many lockdowns and for many places, and also the uh, whole sort of the nature and all responded in a very different way. We have a lot of unemployment issues and all. The construction industry, which we are linked, actually the processing of the materials and the transport of materials almost stopped. So that's how we started thinking that we are actually using most of the virgin materials which are being transported from a far off places. So what are your observations from this present situation of this corona after this 1 year long year? Because a lot of changes which I think for nature it was a pretty good year because the pollution rates had came down, because 2 or 3 months it was a long time period of lockdowns and all. So what are your observations? And I'm sure you might have a lot of interesting things to share on this long period.
I see the government is very good for understanding the digitalization process. So everywhere the digitalization is there, the facilities are here. Now even you say the child's education now is adopted to the mobiles and other things. So the new generation is adopting. The present generation is adopting. It's very difficult to adopt for the over age. I can say 60 years or so. But now they are also adopting the new technologies. IT is available. So actually, there is no difficulty in understanding. We are in front face to face. We are trying to understand our problems. We are trying to give some suggestions for the new technologies in the different subjects, like the building construction. So we can communicate to each other. The communication is powerful as one day. There is no need to even in for any company, etc. The problems are there. We are doing maximum sites in renewable energy. So we have adopted webcams. So there is a virtual project management which where we did not go. Otherwise, every day and weekly visits were there. So we can reduce the cost by the virtual meetings and other things. It's very important. We are reachable. It's not that we are not reachable. Only thing is that we should be truthful to the system, and that's very important. We should not get any the loopholes into it, introduce new loopholes into it, and utilize the system, digitalization process, IT, the simulations and other the optimization process everywhere for every case, and we should lead to the we can say the better environment. The COVID has affected, yes, practically, but we should overcome the COVID effect immediately, and we can. This is what we have proved. So the COVID has not affected only the methodology has affected, the practices and behavior has affected, but as such, as far as the productivity is concerned, it had affected earlier, but now it is improving. So I can say even though COVID is there, it's a regular and we should adopt it, go ahead with it, and see looking at we can say the subject of the national interest and the productivity we can achieve through the different the technologies, digitalization processes and other things. So there is no effect as such. the effect earlier with the first 3 months and the effect now with the same series, hardly there is an effect. We are reachable. Earlier it was not.
Okay, thank you, sir. Are there any questions, direct questions from participants? You can ask if any. Okay, thank you, sir. We'll wind up the session. Thanks for your interesting session.
Okay, thank you very much.
Thank you. Yeah.
Hi, everybody. Have a good day. Thank you.
Okay. So for all other participants, we'll have the next session at sharp 1 o'clock. Thank you. We'll have a break till 1.
Okay. Sapan sir, am I audible to you? Sir, you're not audible to me. Am I audible to you? Hello?
हो गया आवाज आ रही है देखो
Sapan sir, you're audible
हो
to
गया
us
सर
now?
नहीं कहाँ हुआ आवाज स्पीकर ऑफ कर लो सर अभी आया लिंक अभी जस्ट आया मेरा जा रही है सर आवाज
Sapan sir, you are audible to us now?
हेलो एम आई
Yes,
ऑडिबल
sir. Yes, very well, sir.
उनका आवाज नहीं आ रहा अब क्या सर हाँ अभी जस्ट किया था 1 मिनट सर मैं करता हूँ इनको बुला लो ना यार 1 मिनट मैं फिर ऊपर तक लिख दूंगा फिर उसको बुला लो फटाफट
Sir, no, audible ending కూడా ఉంది interview.
हेलो एक बार ऊपर आ जाना हेलो
Hello, yes,
वीडियो
sir.
गेम भी तो नहीं काम
It's audible. Yeah.
am I audible
Yes, sir. We can hear and we can see you. It's all right. Yeah.
hold on इसको बुलाओ अभी डोंट कम इसको
വീഡിയോ ഒന്ന് പ്ലേ ചെയ്ത് നോക്കാൻ പറയാം വീഡിയോ മറ്റേ
Share.
ഷെയർ
हेलो
Yes, sir. Yeah.
स्पीकर तो उनकी तरफ से वो वहां से हेलो
Yes, sir. We can hear. Yeah.
ठीक है सर, यहाँ पे देख रहे हैं।
नहीं यार, सबका जब इतना सॉल्व कर रहे हैं।
हेलो,
Yes, sir. We can hear you.
നമ്മളെ കേൾക്കുന്നുണ്ടാവില്ല. ഒന്ന് ചോദിച്ചേക്കാം. ആദ്യം
Sir, am I audible? Hello, sir. Can you hear me?
उनको ऑन कर दो, ये कर सकते हैं। वो तो होस्ट
അവര് ഐടിയിലെ ആളാ ഇരിക്കുന്നത്. അപ്പൊ അവരെ അറേഞ്ച് ചെയ്തോളാന്ന് പറഞ്ഞു. എന്തെങ്കിലും ഇങ്ങോട്ട് വിളിക്കാം.
खुद आएगा ना।
सर आने ना आने वाली बात ही है, सब कुछ यहाँ से सेटिंग्स हो रखी है। हेलो,
Yes, sir. We can hear you. Yeah. We can hear.
सब कुछ ठीक है,
बट उनका आवाज नहीं आ रहा।
तो सर उनका देखना पड़ेगा। उनको
बैठे हैं भाई साहब।
എന്ത് നമുക്ക് കാണുന്നുണ്ടല്ലോ.
നമ്മളെ കേൾക്കുന്നില്ല. हेलो,
एक मिनट, वो शायद उधर भी बीच में कॉल तो कर रहे हैं। हेलो,
Yes. Yes, sir. We can hear you.
उनको बोलो वहाँ से।
सुन रहा है. कौन सी देखो?
ആളെ ഇങ്ങോട്ട് വിളിക്കുക.
മെസ്സേജ് യു ക്യാൻ കോൾ.
വിളിച്ചോ, അങ്ങോട്ട് വിളിച്ചോ.
ആ ഫോൺ കുത്തുന്ന എന്നെ.
इनको बोल ही दो यहाँ से. If you can please call us.
Yes, sir. We are calling. We are calling.
കേൾക്കുന്നില്ല. അവിടെ വിട്ടു.
सर हेलो,
Hello. Yes.
कैन यू प्लीज कॉल अस?
Yes. Yes. We are trying. We are trying. Call phone. Yeah.
Yes.
योर माइक इज म्यूटेड, प्लीज अनम्यूट योर माइक एंड चेक.
ഇങ്ങോട്ട് വിളിക്കുമ്പോൾ ഞാൻ അങ്ങോട്ട് വിളിക്കാം.
Actually, we can hear. We can hear you. We are speaking to. Chat വരുന്നുണ്ടോ? We can't hear you.
Yeah, we are unable to hear you.
Yes, we
We are able to see you, both of you, but my
Okay.
IT support is there with me. But we are. I think you can hear us through the discussion forum.
Yes. Yes.
But we are not able to hear anything which what you are saying. So probably I think
okay.
just check once more your mic and other things.
Sir, it is working for us because we are logged in from 3 systems and we can hear quite clearly.
Okay.
Can you just do me a favor? There is a pull down menu next to mute.
Sorry.
Mute,
down menu next
unmute,
to
you see
mute.
a down arrow? Yes, and then when you click on the down arrow, there is a settings, right? The third last option, settings.
Settings, yeah.
Yes, so if you click on that,
We have clicked. We have checked the internally the testing.
So
we have done it. So it is.
Actually, we have tested the speaker and microphone as well.
okay. So can you do me another? Can you switch audio? Give switch audio. Like if you click on the arrow again and give switch audio, the last option, then
Switch audio.
yes,
उसी को दोबारा click करिए.
the down arrow.
Switch audio. Yeah.
Switch audio. So first
Right.
disconnect and then reconnect again.
Okay. Okay. Hello.
Yeah, done that now.
You have reconnected also.
Yes.
Okay. Yes, sir.
Yeah. Can you hear me? No. Can you hear?
No, you
Still, the sound is not coming. You can see us, right? The videos, right?
No, we can't hear you, sir. Actually,
You're still not able to hear us. So that's in the
एक मिनट
settings
मैं
you have
दोबारा
kept
join करता
the
हूँ.
speaker
So
as
let us join it once again. Just wait
Yeah,
for
yeah,
1
sure,
minute.
sure,
Again
sure.
log in and
Yeah,
then
yeah,
again
sure.
call you back. Okay.
Sure, sir, sure.
നമ്മള് മണ്ടന്മാരാണോ?
അവർക്ക് മലയാളം അറിയില്ല.
Yes. Hello, sir. Can you hear? Hello. Hello.
So we can hear you, but I am guessing that you can't hear us. Is that right? Can you hear us?
Video.
Okay. So sir, we'll just show you one more option. Can you just please check that? Can you go back to the down arrow right next to the mute and settings? And your first option is a speaker, and there's a pull down menu there. Use system setting, and then if you click that, yeah, you have two options. What is the default option for you? What option are you on? Okay, what is the second option then? Yeah, so like, can you opt for the other one, which is not selected at the moment?
Hello. So can you hear?
No, you can't still hear. Background volume. Your volume and all is on full, right, sir? Your volume on the system and all is on full. Okay. Let me just check that. So we can hear you through this thing also, through the WebEx chat also. I'm guessing you can't hear us through the WebEx chat. So, but the video is clear, right? Okay.
Video ഉണ്ട്.
Yeah, I think we can do that, sir. But let me just call one more person to see. Yeah. Mm-mm. And address. Yeah, I think that will be all right, sir. But can you please hold on a second? We'll just inquire with one more person. The option in the settings, your output volume is also on full, right? In the same option, when you go to settings, speaker output volume is on full.
Speakers, use system settings, speaker.
Okay, speaker दिख जाए ना?
Speaker में देखिए होगा.
Okay, okay. Sir, like you can open tabs, and then if you click on mute the down arrow again, and your second option, your first option, use system settings will be dipped. Your second option, can you click that? Okay, but it's not working. So do you want to? So do you want to use a headphone? Will you be comfortable with that? Yeah, can you please connect to that and see if that works? Yes, yes.
Okay.
Yeah, we can hear. Yeah, yeah.
Yeah, we can hear
It's
you.
correct.
Yeah.
Okay, thank you. You can see the video also, right?
Yes, we can.
Okay, yeah, fine.
Okay, thank you.
Sure, sir.
ठीक है, आप जाओ, करता हूँ फिर, लेट हो
Yes,
जाएगा।
yes. Audible.
तो धीरे करें।
उस स्विच करके जो उन्होंने डिस्कनेक्ट कनेक्ट कर बोला था ना, हमें ये हटा के दोबारा से वो
अच्छा, चलिए।
ये डिस्कनेक्ट कनेक्ट
अब आवाज धीरे कर दीजिए।
कंफर्म कर लो।
Yeah, please speak some words.
Yeah, we can hear you, sir.
Okay.
ठीक है अभी
Okay. Just few seconds, sir. We are inviting all the participants.
Yeah. Thank you.
Yeah. Okay, now we have Leah Roy to introduce the speaker of the third session.
Okay, thank you, sir. Dr. Sapil Tapar is an associate professor in the Department of Energy and Environment at the Cherry School of Advanced Studies. He has over 2 decade experience in the field of energy with expertise in energy policy, climate finance, and energy conservation. Dr. Sapil has completed his doctoral research as well as master's from the Indian Institute of Technology, Delhi. He is a BEE certified energy manager and has several research publications to his credit. In the past, Dr. Sapil has been associated with IREDA, TERI, and Tata Consultancy Energy Division. We welcome you, sir, to the day 8 of FDP. Over to you, sir.
Thank you very much, the host institution as well as the participants. So it will be pleasure sharing my thoughts and ideas related to energy management. So let me then start the session by sharing my screen. So if you are able to see the screen.
Yes, sir, we can see it.
Yeah,
Yes,
thank
sir,
you.
we can see it. Yeah.
So this was the topic assigned to me, and I'll be sharing my thoughts. Maybe you can park your questions for probably the mid session, and then we can take it forward. So we'll be discussing on the overall global energy scenario, the conservation imperative for India, what are the audit techniques, and some of the business models. So globally, we have seen over the last 3 to 4 decades the preponderance of fossil fuels in terms of their share in the energy basket, irrespective of the fact that the renewables have gained foothold in the last 4 to 5 years. The share of fossils in the total energy basket is still as high as 80%, majorly coal, oil, and natural gas. Obviously, this is not equivalent to the power sector, but this is a total energy sector. So oil, gas are also used beyond the electricity sector. That's why the share is as high as 80%. And of the 14,000 million tons of oil equivalent, around 10,000 are attributed to these three fossil resources. You can see in the graph chart beneath the pie diagram that the share of fossils has been increasing over the last several years. Obviously, one kind of asset, which is coal, has in last 3 to 4 years reduced to some extent, but then that space has been occupied by natural gas. So it is not easy to displace these fossils. And this graph aptly shares that obviously the share of gas is rising over the last few years. The coal has dipped, especially in the US and European countries, because now we have some other forms of energy generation from renewables, but still their total share in the energy basket is very high. And with respect to the emissions, energy constitutes 75 or 74%. So that also in a way should be the guiding factor for energy transition in the country. And we as India is among the top 5 emitters. And obviously there is a lot of pressure, and we are really doing a lot of work in terms of going towards greener fuels and adopting energy efficiency interventions. In terms of the renewables, obviously the last few years have seen a tremendous addition in solar and wind. So globally there is around 700 gigawatts each of solar and wind. This figure was for 2019, end of 2019. So we are just awaiting the 2020 figures, but still I think the last year around 120 gigawatts of solar and around 55 to 60 gigawatts of wind has got added. So we have around 1500 gigawatts mostly from solar and wind. In terms of the energy share, as we saw on the first slide, the share of fossils is as high as 80%, and the modern renewables, which primarily includes solar, wind, the biomass, the hydropower, is just 11%. Similarly, in terms of electricity share also, the renewables, the newer renewables, the share is not more than 10%, because we do have hydropower, which is around 15%, and some part of nuclear power is also there. So the non-renewable capacity is around 70% plus, and which also includes nuclear power to some extent, around 5%. But still, with so much of focus on wind and solar, their share in the total grid volumes is very low. Why? Because their capacity utilization factor, the PLF values are very low. So for a solar project which generates a PLF of say 80-90%, the coal project would not, the coal project would be generating a PLF of around 80 to 90%. The solar project or the wind project would be generating not more than 20-25%. So even with higher capacities, the actual generation is not so high. And we have seen over the last 2 to 3 years, the CO2 ppm levels have breached 400 mark. And they are really rising every year. Even during the pandemic, there was a slight blip, but then still again it has started rising upwards. So that is a reason we should practice the models adopted by various countries to reduce their energy conservation. In terms of the use of energy in the Indian market, majority of the use is attributed to industry and residential sector. Transportation and other services have mostly been constant. So this also in a way would help the policymakers to devise appropriate policies where they can work to have major impact on the use of energy and its emissions. This is a kind of Sankey diagram for the country, and this gives on the left part we can see what all sources of energy are there. So mostly it is coal, petroleum products, partly hydropower and gas. On the right part we can see the uses of these sources. So obviously around 20% of the total energy is used for electricity generation. A lot of non-electricity use is still there, whether it is transportation, mostly oil, or industry using raw material, or for agriculture purpose. So if we develop policies for these all sectors, then only it will be meeting the global commitments, the global climatic commitments made by the country. And we can also see there are a lot of losses in the energy conversion. So those also are the areas where we can reflect upon. And similar to the global share, the share of fossils in the country is also very high, as high as 80%. Obviously, the share of gas is not so high, so that is taken by coal. So 80% is from coal, oil, and natural gas. But they are saying that they will be substituting coal with some other fossils, mostly gas. Why? Because these sources are energy dense, they can be transported easily, and they are like 24/7 resources. So you do have the facilities to generate power at any place, anytime using the fossils. But then we have to do away with fossils. So that is a challenge. Another important aspect is the high dependence of the country on oil imports. So we have seen the prices of petrol, diesel rising in many cities, and a part of it is also attributed to the global oil prices. So as part of energy security and for its own economy, the government is contemplating to reduce the import dependence by improving the energy efficiency, as well as trying to use newer fuels like bioethanols, like hydrogen fuel, like EVs. In terms of the installed power capacity, we have around 380 gigawatts, which is mostly coal. Then renewables have come up in last few years. Around 1/4 of the total capacity is attributed to renewables. Hydropower is another 10%. But in terms of the gross generation, the share of renewables is around 10%, which probably was, I think, 11% in the last financial year. And the major 78%, 79% is attributed to coal. This is also the major reason why the country wants to go for a energy transition. Another important aspect for industries and large consumers is a high cost of energy in their total expenses as part of the total production cost. This also makes the Indian industry vulnerable to international competition. So when we have in India industries getting power at higher rates than their competitors in other countries, obviously they can't meet or compete with them on equal footing. That's why the government has launched recently the production linked incentive scheme, wherein they'll be providing some kind of support to the industries, which will generate revenue as well as employment. Then another important aspect is the power consumption in country is very low, though in the cities the consumption patterns are similar to the Western world. But on a whole, when the country is rising fast and the economy is growing, and we are expecting more number of people to get out of poverty line to enter the middle class, we would have huge impact on the per capita consumption of energy or electricity. And lastly, we do have climate commitments. So as per a recent statement by government, the targets are 35% reduction in the energy intensity. We have already achieved 25%. So we have another 10 years, but we are on track. But still, for reasons mentioned above, including energy security, energy imports, high cost of energy, energy efficiency needs to be imbibed in the ethos of our behavior as well as industrial processes. So what are the major triggers for energy conservation? A high share of fossils, high import dependence, high cost of energy, and some kind of regulatory requirements. So these things obviously are the major precursors for anybody as an individual or as a professional, industry professional, to uptake energy conservation measures. Now, what has been said over and over again, that what you can't control, what you can't measure. So if I have to control my use of energy, maybe at my home or at my office, I need to know what kind of consumption trends are there in my office or my home. So there is a concept called energy management. What it says that the judicious use of energy to maximize my profits and enhance my competitive position in the market. Effectively, why? Because energy is a major cost player in my total production cost. And the goal is to improve my services at the least cost and obviously improving the environmental component also. So this is a broader definition of energy management. And energy audit is the second part of it, when we actually verify and analyze the use of energy in any kind of process or an industry. And this also includes submission of the technical reports or some kind of audit report for follow-up action so as to improve the energy efficiency of my plant. So what is important here is that we need to define a benchmark, a kind of reference point. That today my consumption is X kilocalories, tomorrow it will be say 0.8x, 0.9x. So the benchmark is extremely important because then that is a reference point and where I can work upon that these are the interventions and I have reduced my consumption to these levels. So the objective of audit is to basically find out all the energy inputs within a utility or a service, to establish the patterns of consumption, which shop floor is consuming more energy, which of my office block is consuming more energy, and relate energy inputs to the production output. What has been my output using X kilocalories of energy? Say I am manufacturing pen or maybe a car or maybe a computer set. So I'll be using some energy. So what is a good way that I can relate my production output to per unit consumption of energy? And the next part within this kind of audit process would be identify the areas where wastage is there, kind of opportunities to reduce my energy consumption, and finally adopt some measures or interventions to reduce the consumption. Now there are two types of audit, a basic audit and a detailed audit. Obviously no company, no institution would go for detailed audit in first go. They would invite some professionals to do the basic audit, which will help them to identify what are the opportunities in terms of saving and the areas where they can do the intervention. So that is a kind of walkthrough audit or the preliminary audit, the basic audit. So the experts are called in, they participate, they take basic information. This is over not more than 2 to 3 days and basic consultancy fee of say few thousand rupees. They will immediately say that the industries which are your competitors, their consumption is not so high and these are the possible pilferage areas. So your consumption trends show that your consumption was say more in the evening or the afternoon hours, or you have certain machines which are running idle, or some kind of leakages are there in the compression wall. So those things are captured in the audit, basic audit, and then based on the audit report, the management may think that okay, rather than depending on a 2-day audit which are just kind of reflecting the base overview of my plant or a system, let us go for a detailed audit. So the initial audit report, the basic audit report says that yeah, there are opportunities. Then the detailed audit is followed up, which is a rigorous audit. So this requires detailed planning and implementation of the measures. So energy audit attempts to balance the energy inputs with the output streams. So what kind of energy, what quantity what quality of energy is flowing, which form of energy is there, steam, oil, water, electricity, and then they develop the energy balance diagram, like we saw for the Indian case. And a part of it would then reflect on what are the areas where the major consumption is there. And then they will evaluate the performance of the equipment and obviously then suggest the measures. So the audit basically starts with review of the energy bills, whether it is a contract demand, the power factor, the grid imports, the use of DG sets, the options to use, say, rooftop solar. And then they will further then work on the efficiency, check the efficiency or efficacy of the equipment. What is the performance of transformer or motors or pumps, whether any kind of reduction is possible, because obviously when the equipment is initially placed, they always have certain margin, which is sometimes very high. So the equipment, when it is used with say 40-50% operational values, the loading part, the efficiency levels are not so high. And you are also wasting money for procuring higher wattage or higher level systems. And then similarly, we can do assessment of the cooling tower, the boilers, the turbines, the air compressor, and find out, are there any leakages, what are the temperature points, any kind of hotspots are there, insulation levels are good or not, whether any kind of waste heat recovery mechanism is there or not. Because these are very simple thumb rules, we can be easily followed by the energy auditors. We can even check the illumination level, whether the lighting is proper, whether the lux levels are maintained or not, whether the insulation levels are appropriate. And then finally, we divide the audit into a 3-step process. The first step is a kind of walkthrough audit, basically to discuss with the people, the management, what kind of concerns they are having, what kind of options they are having, what kind of interventions they desire. So you talk to all the line managers, see the shop floor yourself, take the data from these people, prepare a questionnaire, and then in the next step, you develop the single line diagram, you check the consumption of various input energy formats, steam, fuel, power, water, and you develop the energy and material or mass balance diagrams. You also check the equipment like motors, like boilers for their performance, efficacy basically. And based on that, you identify the ENCON. ENCON are energy conservation measures. And then you do the cost benefit analysis, whether these activities can be done with what kind of investments and what is the kind of payback period. Phase 3, the post audit phase, probably this is the missing link in the Indian energy market. So we do have a lot of audit reports, we do have a lot of interventions, but very few companies actually go for post phase 3, wherein you actually measure whether the desired changes have been made, whether we have achieved the energy reduction or energy efficiency in my processes or not. Because there is a conflict of interest between the auditors who will be implementing the measures and the evaluators who will be actually checking whether the interventions were really up to the mark or not. And this is a typical report, energy audit report. So you initially introduce the plant, what are the fuel use, the specific energy consumption, the efficiency of different equipment. You develop the flow diagram, energy and the material flow diagram. What are the inputs and what are the outputs? You then capture the utility systems, the electricity, the steam, water, and the compressed air. And then finally, you categorize the recommendations based on their level of efforts or level of intervention, whether it is medium or low in terms of their cost and the inputs or the efforts required. So if we target the energy savings at 3 levels, obviously the initial low hanging fruits are just to maintain good housekeeping, the best operating practices without any kind of other retrofits. So this basically is change of the behavior. So you say basically you switch off the lights when you are not there. You switch on the systems when nobody's there in the office or maybe a shop floor, or you have the AC settings at certain temperature settings for air conditioners, or you have certain kind of behavioral changes among the employees, among the staff. You have the proper loading of the motor so that there is no idling and no wastage. The next level, the level 2, is a retrofit. Just try to add something in the process which may require some investment, but then there are obviously benefits are more. The third would be probably adding some new equipment or changing the entire process. So maybe an example can be that I do have CFL lamps in my office and I replace them with LEDs. So this can be a level 3 intervention. The cost is high, implementation time may be high, but the rewards are there. So based on level 1, 2, 3 and the assessment by the management, they will pick and choose among the options offered in the energy audit report based on the expected reduction in their energy use. So energy audit is a continuous process. It is like any other process wherein you keep on improving. So you have discussions, you have some recommendation and implementation, and further you work on the process so as to improve it, like an ISO process. So what are the techniques? Simple, very simple techniques to do energy management. Anybody can do, like you and me. So there is a very good important concept of specific energy consumption. So you have any kind of industry or even any office, maybe your own campus, university campus, it will be taking energy in multiple formats, and there will be some output or some per capita consumption, if you say. So what is the way forward? You, on the left part, there are multiple fuels. You have the calorific value of these fuels. You multiply the calorific value with their quantities. And finally, the value is described in terms of kilocalories. On the right part, you have the product or the output from the office. So the specific energy consumption is the total inputs divided by the outputs. Now, if I go to a cement plant, they would say that my use of energy is, say, 1000 kilocalories for 1 kg of cement. So that would be a kind of a baseline. Then I can give the target to that company that you reduce it by, say, 5 or 10%. So instead of 1000, you have 900 kilocalories for your production of 1 kg of cement or steel or iron ore, something like that. So these targets can be given based on the baseline, and then if you achieve or if you overachieve, that will be good. If you don't achieve, then further actions are required. But if it is very important to know that there is a boundary condition to be set up. That this is my plant boundary. What are the inputs are? These are the 5 inputs. What is the output? This is the output or 2 number of outputs. So I can easily calculate the specific energy level. Even for buildings you can do. You would be knowing as an architect that per square feet how much energy is consumed in a conditioned and a non-conditioned area. So those can be the baseline targets, and based on that the industry can decide or the company can say that, okay, let me work on, because my competitors are having lower values of SEC, so I can work on that. Another is a simple tool to establish the efficiency of a process, so it is known as Sankey diagram. So what actually is there, that what is the energy input and what are the different kinds of energy output. So effective utilization may be very low. Say in this IC engine it is as low as 25%. For a coal plant it is as low as 35%. So this is a very good tool to identify what is the total utility of my process, what is the remaining value, say 60 or 70%, and within that how much I can extract the waste heat, to utilize or improve the process. This is also a very excellent tool which can be done for some processes. Then there is ISO 50000 series, which is also a very good tool to implement energy management in a large institution. So you have energy policy, which probably would be dictating the overall energy management system within a office or a company. You do energy planning, you have dedicated cell, you implement the measures, you audit the measures and you implement the recommendations. And this keeps on feeding back to the energy policy. This is also one of the very good tool to work on energy management system. Now, interestingly, globally, it has been proved many times that to reach those carbon goals, energy efficiency provides a better bet, even higher than renewables in terms of its efficacy. And these are very low hanging fruits. To put up a solar plant, you require maybe 30-40 million rupees per megawatt. But to do energy efficiency and to reduce that amount of power would not be that much costly. So suppose you all of us take a pledge that you will be saving say 5% energy by taking some measures, behavioral changes, by using energy in the most efficient manner. We can obviously save energy, which is similar to or higher than what renewables can generate. So it is absolutely nonsense that we are generating more of green power, but we are wasting it. And this is a kind of calculation for GHG emissions. So you have the GDP growth, you have the economy, the energy intensity of the economy, you have the carbon intensity of the fuels. These three multiplied by the population gives the total emissions for a country. Now I have the option to reduce, to work on all the three. So do I need to cut the GDP? No, I want GDP to rise. Can I work on the energy intensity? Yes, I can work on the energy intensity by reducing the consumption, by making the SEC levels more stringent. So it can be for residents, for transportation, for industry, for commercial buildings. On the third part of it, I can also reduce or by switching over to renewables. So all three are equally important when you multiply them and we get the total emissions. But interestingly, the easiest part is to economize on your existing kind of usage trends. The behavior change is tough, but when it happens, it is the most profitable. It doesn't require any kind of inputs. But there are challenges. Even if I say the energy efficiency measures are proven to be effective for global climate mitigation and meeting the local regulations. The challenges is the concept of negawatt. If I save some energy and I attribute it to my behavior change or some energy efficiency interventions, it is very difficult to prove. So negawatt is a negative wattage. So I can generate solar power and I can take the credit that yeah, you can just see directly the meters are there which will prove that the solar is there. But no meter would capture the savings. Very difficult. So it is a challenge even for experts how to deliberate on that, because when there is a negawatt concept, nobody would be able to believe you very easily that these are because of my efforts. Then next important thing is the baseline. Very, very difficult for industries, for even households. So you have n number of factors or parameters which are impacting. So say I am a faculty in the university, I would say that the baseline energy has increased or decreased. So factors may be the number of classrooms occupied, classes happening in post lunch hours, and there is more requirement of air conditioning. The classes happening on more number of days per year, or other way around, the temperature was good, so I was using lesser of air conditioning load. So that can also be reason for reduction in my consumption. Or there can be a simple thing that maybe the lift is not working for say 1 month because of some issues. So people are adapted to now stairs. So that will also be helping me reduce my energy. The other challenge is service providers. These are very, very few. The energy auditors are there, but then they are mostly working on energy intensive industries. For typical small institutions like us, like yours, very difficult to find auditors who will actually do the hand holding and work. Another challenge which I feel, which I have not mentioned here, is the ownership. If I save some energy, will I be counted as part of my work or not? How will I be benefited? Will I be provided some kind of incentives, awards? I will ask the electrical guy in my office that will switch off this 5 systems or 5 lights in the 5 rooms. But why will the person do it? So the ownership and the level of incentivization is missing because the baseline is difficult. So if this guy tells me that, okay, because of my efforts, the electricity consumption has reduced by 5%, and at least you give me some awards, maybe monetary awards, something like that, recognition. I'll say that no, not because of you, because of other reasons. And finally, the constraints on funding part. If it is level 2 or 3 exercise, who will fund the energy conservation efforts? Because the behavior is very difficult to change, the ownership is difficult and difficult to prove the megawatts. So funding also is difficult. So if I go to my management that I need to put a solar plant to give me XYZ fund, they'll be happy. But the moment I say, no, I want only 20% of that funds for energy conservation activities, they would say no. So those kind of mindset is still not there to promote energy efficiency. And these are the issues in financing. So quantifying the deemed savings. Basically, if I say that these are the possible savings because of my activities, nobody will believe. Second is the small size of the projects, like smaller, say few thousand rupees. So no kind of consultant would be happy to come. The banks will also not be very keen because suppose a municipality, a corporation goes to the banks that, okay, they want some funds to replace the street lights with LEDs or solar street lights. But these are spread across the utility or the DISCOM or the local city, say 5,000 street lights. How should I securitize the assets? And then the other concept is normalizing, which I was telling you that very difficult to quantify the savings. So basically, how should I normalize the diversity of work? So university, your university may be open till late in the evening for some research work. The other campuses may not be open. So how should I normalize the data? 2 shift, 3 shift, the fuels are different. Some universities may be using some fuel, some institutions may be using gas, some institutions may be using electricity. So the efficiency levels are different. And then these interventions are typically customized for each institution. So there is no standard or no standards which can be replicated. Like we can have a LED bulb, but that is a common thing. But other than that, a lot of interventions are there. Insulation is not there, or the building orientation is not proper. How should I work on these interventions? And I was telling you the priority is there from the renewable sector. So that's why we are losing the kind of game. So internationally, renewables are a big hit. But when we talk about energy efficiency, the kind of response is not so high. So what is a good thing? That there is a concept called ESCO, the Energy Service Company. What they will do? They will act as a one-stop shop for you to do all the things. So whether you want to do the audits, whether you want to take the approvals, the loans, or you want to go with some kind of energy efficiency intervention and procure the equipment, install it, monitor it. So they will do everything. And what are the 2 business models of ESCO? So these are the 5 activities with the ESCO: audit, the installation of the equipment, the verification of the equipment installed in terms of its efficiency, the maintenance of the equipment, and other approvals and the banking services. Why will ESCOs come to us? So there are 2 business models. The guaranteed savings, which says that the company, the host, basically not the ESCO, the host institution will say that, please do this work for me. ESCO will say that, okay, I will do the work. I will guarantee that based on my assessment, these will be the, say, 5% savings are possible. but you have to provide the funds for putting up the project or implementing the measures. If these savings are not achieved based on my recommendation, I will be compensating you. That will be the guarantee from the ESCO. The second is the shared savings, a kind of success fee. ESCO will say that, okay, let me put in the instrument from my funds. Whatever the savings are there as per the baseline established, you will share a part of savings with me. You can take it, a part of it, for your own benefit also. So you are in a way dividing the savings. The entire risk is taken by ESCO, but the only thing is that you need to sign on the dotted line of the baseline levels. So say last 3 years, what is the consumption in summers or winters, or the annual consumption per month average? And then they will say that within that, I will reduce it by 5%. So if you are 5% savings, if you are saving energy cost of say 5 million rupees, they will say that, okay, because I have done all the investments, you give me 4 million to me at least for next 2-3 years, I will recover it. And then afterwards, you become the owner of the new assets and you will be able to take all the savings with you. The guaranteed savings is, which is like, ESCO is very professional but not very rich. They are coming with that kind of report in terms of the energy conservation methods or the interventions based on the ESCO's report, and they will take their own financial obligations. But when the energy savings are not achieved, ESCO will pay the shortfall. So the customers are in a way provided some comfort, or the institutions, so that they are having some faith. And this is the shared savings, wherein ESCOs take all the kind of hit. They directly face the client as well as the bank. So they will take raise the loan funds, everything, but they will also take a major part of the energy savings. So for the industry, it is not much of a headache because the entire one-stop shop ESCO will do all the work. Now, what are the new business models, which I will also request you to share among your students, or maybe ask them to be innovative. So in a country like India with many ESCOs, there is a super ESCO called EESL, the Energy Efficiency Services Limited. So they have come out with the Ujala scheme, wherein they have really brought a revolution in the country. We have more than 200 million LED lamps, and most of us are going for that. So what was the business model? They aggregated the demand. They came out with very large million lamps orders. And then interestingly, they also tied up with the discoms. So suppose their lamp was rupees 100 or 200. It is difficult for me to say replace all the lamps in one go. Say I got 10 lamps. So 100 into 10 becomes 1000 rupees. So what the company will do that, okay, you only pay 20%, say 200 rupees. I will replace all your 10 lamps. But because you are saving some energy, so every month you have to pay a certain amount to me in your discom bills as an additional cost. So you in a way are paying as a kind of EMI, which will be proven based on your actual use of the lamp. So you are saving, say, for every lamp rupees 20 per month. So you got 10 lamps, so you are saving 200 rupees. Out of that, you probably pay 150 as additional cost to the discom for say 10 months, 12 months. And that will be a kind of a win-win situation for both the parties. This was a kind of innovation which was brought in by Super ESCO. And then we have seen the Ujala scheme, the smart metering scheme, the energy efficient fans and the air conditioning scheme, which is coming up fast. So there is kind of aggregation of orders which will lead to lower cost or lowering of cost and prospering of the sector. Another thing which is coming up is energy as a service, EaaS, like software as a service, SaaS is also coming up. So maybe 2 or 3 students can join, form a kind of ESCO or an energy company, and then they can manage the energy resources for that company. So they will try to see what is the best fit for that. So they can say that, okay, I will manage your energy portfolio, and this was your cost for last 3 years. The average cost per annum, say 10 million rupees. So I'll manage by 9 million. So the savings would be partly coming to my pocket based on my intervention. So they can do audits. or they can do the best practices, share the best practices, or they can even handle your portfolio. So rather than taking all the power from the grid, they can say tie up with some other low cost solar providers or some other heat pumps which are newly coming in the market. And we have seen globally there are n number of energy startups. And in the university also we have seen some students really thinking of setting up their own energy ventures. So I would say that energy conservation is the most easiest and the desirable thing without any kind of financial obligations, but very high level of energy savings. Energy efficiency is the next level wherein we actually use or install some efficient equipment, replace the equipment, kind of retrofitting. And third is the renewable energy in the tire. So this is the energy pyramid. And I hope we would focus on the bottom of the pyramid to make it more functionable and make it more relevant for the masses. So thank you. I would now hand over the podium to the organizers for any questions. Thank you.
Hello.
Yeah.
It's 1 minute. Yeah. So can you see me?
No, let me stop sharing.
Oh, yeah, fine, sir.
Yeah.
Okay, yeah. Thank you, sir. It was an insightful session. We have a lot of questions from the chat boxes. So before going to that, just to inform to the participants. I would like to inform the participants that the Google form for the attendance has been shared in the WebEx chat. I also request you to turn on your video so that the attendance can be recorded. All the participants, please turn on your videos for a few seconds, and then we'll have the question sessions. Yeah, fine. So can we go for the questions now?
Yeah, please.
Yeah, I'm just summing up a few questions which came up the chat box. In between, if participants have any questions directly to us, to the presenter, they can also ask. Yeah. So there was a slide which showed about the low per capita consumption. So I was just for the clarity, what does it actually mean? Low per capita consumption means for a country like India, our consumption rates are really high. Right? What did you actually meant in that slide?
Yeah, so low consumption means in terms of the global average, the value of India is around half of the world average. So if we see that we are rising economically, the GDP growth is expected 7 to 8% in the coming years. So obviously the per capita consumption would rise. So that would entail our efforts to reduce the energy consumption. Otherwise, it will be difficult for us to import so much of energy, oil or coal in the coming years, or natural gas. So that is a kind of imperative for us to work further to reduce the energy consumption in different sectors. Otherwise, it will be very difficult to handle so much of energy imports, and the energy basket needs to be further widened or expanded so that we have newer resources, local generated resources, as well as energy conservation efforts. So suppose I'm having a technology of saving using LED lamps or maybe smart systems which are using lesser energy. Those can be the kind of buzzwords in the coming years so that the average per capita consumption is not rising over a certain kind of levels, maybe the global average. Because in terms of the energy consumption, we are having only 6 to 7% of the US levels.
Okay.
So 1/16 of US, 1/16 of Europe. So that's the reason we should be very careful to go how to move forward. Thank you.
Okay. Yeah. So there's a question like actually each of us are consuming concrete at a higher level. That means even if our houses are small, we are actually using a lot of educational buildings, office buildings, I mean, a lot of infrastructure, bridges and all. So the per capita consumption of concrete as a material is really high in a developing country like India now. So what is your take on those? Because each day there are thousands coming from villages to cities, and it actually is the main reason why we need a lot of infrastructure. A lot of cars are also coming to the roads, and also the infrastructure is going on increasing. So how do we actually
So,
evaluate those things?
So,
Huh.
yeah, maybe because I think you are all from architecture background, so it will be better
Yeah.
place to answer. But then my thoughts would be that we can go for some traditional architecture systems using natural elements like wood, like bamboo. And secondly, we can have a mixed development for the cities, like smart cities having a same set of office being used parallelly for, say, a hotel in the evening or a mall on a weekend. So kind of common user facilities would obviate would minimize the construction of separate facilities for, say, different offices, different hotels or working places. So kind of co-working places or co-spaces would be a very, very relevant thing. Like we have Ola and Uber. So similarly, we can have a co-working space wherein there is lesser need for putting up the newer office establishments. Obviously, individual houses are required, but at least for the office part and the institutions, we can have some kind of co-working space. Plus the mixed mode cities. We have vertical buildings coming up. So smaller kind of disturbance to the environment also, and multiple uses. Thank you.
Okay. Yeah. Shall I further go with questions? Any participants? Yeah, I'll further go. This something which you said about import dependence in the starting slides, actually. So there's a lot of dependence on oil, but now, as you mentioned, there's a lot of vehicles and all coming for this electricity, which will work on electricity. Then there will be a major shift on electric vehicles. And apart from solar, I think there will be really high consumption of electricity, which is actually coal produced. In country like India, I think the coal produces the major electricity which is required by the population. So again, it makes a big shift on a different source of energy. So what is your take on that? Either from both are big issues. Either we are using the oil in a way, or we are consuming coal in another way. So what's your comment on that?
So there are two aspects to this question. One is the energy security, another is the energy emissions. So obviously, it doesn't make a sense for us to shift from coal to oil to coal, even if with EVs to be using the batteries. Batteries to be used in EVs which are charged by coal-based electricity. But what you can also appreciate that government has been putting a lot of action on the solar and the wind projects in the country. So we have the share rising, though gradually over the last few years, now it is around 11%. So even if we go in the next 5 years, the EVs will only come probably by 2025, 30 in a major way. That time we probably would be having around 25% share from greener sources. That in a way would be helping us. But then we have to save the economy from the vulnerability of energy imports. So suppose there is a Gulf War, difficult for us to import energy. Shipping lines are all blocked.
Yeah.
We have to have very good relations with the countries, otherwise they will also push some kind of their agendas in our climate policy. So this is a kind of trade-off. But maybe we are also working on green hydrogen fuel. Government in recent budget has highlighted the importance of the hydrogen as a fuel. So we can think of multiple ways to run the vehicles by multiple fuels, green fuels and locally available fuels. Importantly, for countries even like Germany, they are not doing away with coal. You can see that they are importing gas, they are having lots of solar and wind, but they are still having good amount of dependence on lignite, which is the only fuel available in that country. So energy security is also paramount. In case of any kind of adverse situation like a war, so we should have some locally available systems also.
Okay, thanks. The concept of negawatt was really new. Actually, most of us didn't knew about it. Can you just a few more describe about those things? You said about the ownership of energy, giving incentives, the form of incentives. So primarily, your the concept, the pyramid which you actually presented the last, actually made much sense, because it's mainly the energy conservation, and then on the top comes the last priority comes the energy renewable. So mainly the industry is driven by energy renewable products, like the ACs and all are coming with 5 stars, the fridges and all. So it's all a different sort of business model which is actually going. So you are actually focusing on the concepts of one small concepts, which is like ownership of energy, who will give an incentive to a person who actually switches off the light, fans and all. So are there any projects or something sort of things which you have implemented and which actually really worked on those things, on the simple things actually, which made a big difference over the years? The concept of megawatt.
So what we did that at the university campus, we had smart meters installed by one of the energy startup. And then we gave a target to our electrical team that these are the consumption patterns for last say 3 months. So we need to work on and identify the areas. So there's a concept called vampire power. So suppose you are now, suppose I move out this, you can see the room is all vacant behind me. This is the kind of media room which you're having with kind of good insulation. So noise doesn't go out of the room. It's very easy to sit and deliberate or have a lecture. If I go outside to my cabin without switching off the lights, nobody will be watching. But then that is a kind of wastage. So this kind of sensitization was made available to these guys. And then we also apprise the management that unless you incentivize these guys, so you have to describe or calculate the SEC levels, the specific energy consumption levels for my floor level kind of consumption or a department level or a laboratory level. So I will give you two insights. One is that when I used to come to the office, the Delhi is very hot, so we had the air conditioning load, especially for 6-7 months in the year. So I was wondering, I am coming at 8 and the ACs were already switched on. And there was nobody else in the faculty cabin areas. Sometimes we have to come early for some lectures or laboratory classes. So then I checked the smart metering system. I found that, yeah, the air conditioning load was switched on as early as 7:30 because the electrical guys will only come in the morning, switch on all the lights, go back to the seats.
Okay.
What we do is simple implementation that, okay, we'll say that the guys will not come. The faculty members or the students who are coming, they will switch on from their own end. So it was a great saving. So every day we saw around savings around 40 to 50 kilowatts for 1 hour. So it will be like 40 units per day, around 1200 units per month. So that is maybe 10,000 rupees per year per month saving. It's a very simple activity. Another thing we found out that we do have a hostel air with solar hot water systems. When we measured, we thought that in the night, in the early morning 4:30, there's sudden load. And we found out the heaters were not working properly, the solar water heating system. There was some kind of burst, and they were all relying on the electrical geysers, basically the electrical elements. So we saved 10 kilowatt of that also by getting those systems repaired. Then, but interestingly, we also employed LED model in the campus, the first kind of campus in India with totally LED lit, but totally on ESCO model. So we didn't pay any money to the company. We said that, okay, 10% upfront, okay, but every quarter you take some kind of money, kind of EMIs, because we will be saving that money. So I reduced my load from 50 kilowatt to 25 kilowatt. So if I even have 4 hours running every day, I save 100 units per day or 3,000 units per month. So that will be around 30,000 rupees per month. So that is the money I used to give to this company. So this kind of interventions we did. But obviously you are right that these needs to be institutionalized, because I was close to the management. I was able to influence them. May not be possible in all places, especially the government institutions.
Okay. So one more question which came was like the ESCO model. Actually, does it require that it should be a big project of this much square feet or something for the company to pitch in and actually work on those models, or can it be done for residences? What is the scale of projects actually which can actually try out this sort of models?
So honestly, ESCOs, there are around 200 ESCOs in the country as recognized by the Bureau of Energy Efficiency. Now,
is it an Indian venture? Or I'm not aware of it, so that's why I'm asking. What is it actually?
So people who are energy auditors,
they
have to get accredited by the Bureau of Energy Efficiency by a form of a Viva exam, and then those companies can start their ESCOs. These are rated by financial institutions like CRISIL and ICRA. That is a grade 1 ESCO, grade 2 ESCO, based on the French substance. Even Tata Power is an ESCO. Even Reliance is an ESCO in a large way. Even PTC India is an ESCO.
So it's mainly the business model as such, right?
Yeah, so business model is two models are there. Typically, when you actually save, when you are very confident as an ESCO that, yeah, this would be saving me, so let me put in my money. I will take all the benefits, part of it, mostly from the initial years. After that, it will come to the industry or the institution. The second model is a bit difficult, that you ask the company or the host to put in the money, because I am somewhat comfortable in my due diligence, but I am not that rich to put in my money as an ESCO, because ESCOs are like 3 or 4 people who are joining together to start a company, the smaller ones basically. But you are right that for institutions, smaller institutions, very difficult. Suppose I am having a house, a 3 BHK house. I want to do some energy interventions, efficiency interventions. ESCO will not come because the company would require certain kind of budgetary support. They will say at least give me some few thousand rupees for a consultancy fee, which will not possible for smaller households. But that similarities can be made as a best practices, which can be then replicated. Like solar rooftop scheme in Kerala is there. I know some students are there from Kerala also. So they were giving me the ideas that rooftop households are there. There's some subsidy from the Chief Minister Fund. So a single company will not come to your rooftop to put over 2 modules, 3 modules. No, they will take the entire area of say 1,000 households in a colony, big office or setup. So that kind of aggregation can happen, like the Ujala scheme for LED distribution. So that kind of gap is still there in the Indian market. That's why we are asking the faculty members on esteemed faculty members who are part of this discussion that they can take these ideas forward to their students.
Right. And lastly, there was a few slides on the energy startups. Like the youngsters of India is taking up those energy startups and all. So what are the government policies and all which actually help this sort of startups? Because as you said, it's actually a very huge task to actually take the energy startups and make it viable to a good business model and all. So can you just share your thoughts on those energy startups and all, which your own students would be doing in IITs and all?
So startups are coming up in energy as a service in a big way. So we have the smart metering system here. There was a professor from a nearby institute who has started his own kind of. So he was a professor in the department of IT, the information technology. He devised a small kind of coding software, and then he used simple instruments as data loggers to put in the data on kind of a sheet or kind of a diagram, which will tell you how much energy is consumed, what is the kind of real-time use. Now, there's an inflection between the data and the energy part. So suppose you have engineers from the IT part, the software engineers, and the experts who are in the energy field. So they can probably work together to have a startup. Government is providing under the startup scheme some funds to these kind of entrepreneurs. And SIDBI, like the SIDBI bank, is providing some low-cost funds. But what I am saying is that unless you have a good working model, it will be difficult for you to grow. If there is a good working model, automatically there is no need for you to have that kind of money. Automatically the companies will come to you because energy is a very good cost item in any establishments. In the university, we are paying more than ₹1 million per month as electricity bills, in spite of all the energy efforts. So for larger campuses, huge bills. So if experts ESCO comes to you that okay, I will reduce the energy consumption, they will be most welcome. And the interventions are mostly non-technical. So it doesn't require more of brains, just commonsensical ideas and some kind of IT setup to capture the real-time data. So we have these mother dairy booths in Delhi, which are selling the milk, the government dairy booth. So what the people used to do, they will open their refrigerators for a long time. They will not be careful because these are not owners, these are just franchisees. All the bills are paid by the main company. So what this company has done, the startup which is engaged by us, they put in the smart temperature sensors in all the refrigerators, and they will have a buzzer. After, if there is a refrigerator not closed within 2 minutes, say 100 seconds, automatically some buzzer will come, please shut it down or close the refrigerator door. So commonsensical things, not much, but then some interventions are desirable from the government also, but they are doing. And you can find from the website, a lot of startups have come in the energy area of energy savings, and a lot of companies are mixed renewables and energy, kind of a you can say co-model. So they will take the energy assets. So right now, 2 of my students are doing in a Maruti ancillary factory in Noida, in nearby Delhi. So they are working to develop the energy policy for that company, that how it can reduce the energy, whether it is by renewables, whether it is by energy efficiency intervention. So this kind of a model is coming up, energy as a service. Thank you.
Okay. Yeah. So, and final question, which is common, I asked to the other person also. It's becoming 1 year for this March 21st after these shutdowns and all. So what is your take? Are you actually, as a energy conservation are you actually happy that the corona had changed the lifestyles of people? Most of us have started working from home. We are now comfortable with online teaching, online learning, and all those things. The pollution has came down to some extent. So, what's your take on this whole scenario? And what even after the corona goes away, what should we actually study from this, and what should we take forward?
It's a very interesting question. Obviously, it has really made life in a way different. So there is a two world now. AC, DC, AD was there, BC was there. Now post-corona or corona world. So we would have obviously some changes in our lifestyle. Especially, you are right in saying that we are in a way saving a lot of efforts, money, resources while coming for these kind of online discussions. So you are saving on that also. Secondly, we are also somewhat more sensitized towards environment. If you discuss the environment, like Uttarakhand, recently there was a disaster in a hydropower tunnel. So we are in a way somewhat more considerate towards environment. We should be more careful towards wildlife, towards biodiversity, because these are all important parts and parcel of our, you can say, life. It should not be that I only see life as 50, 70, 100-year life of my own self. It should be for next few generations. So that is a kind of takeaway I would have from the COVID, that we should be very sensitive towards whatever we're doing on all the fellow beings, whether they are humans or even others, even flora, fauna, any kind of impact is there. So we should be very, very considerate. And it is good that people have got more sensitized. And this online also has helped us that we can reach out to more number of people rather than having only a class 30 students. I can teach 300 students. I can share my ideas with, it's a kind of teachers of training. So TOT concept is very good. So my ideas, maybe some of the ideas can be taken forward by the faculty members here to their classes, which will be useful when they are sharing new thoughts. So maybe a good thing. And interestingly, we have all cobbled together to work out solution. Right? Like Prime Minister Modi sir was saying that India is providing vaccines and other best practices to the world. So in a way, learnings from India for world and other kind of best practices sharing in many areas, including health, including energy is also a good coming field, and also in terms of the global growth kind of paradigm shift towards sustainable development.
Okay. Okay. Thank you, sir. There was a lot of information and a lot of things to think from here on. And thank you for the interesting session. Okay. Thank you, sir.
I also look forward to your discussion further, and probably you can always write back to me if any queries are there.
Yeah.
Thank you very much for your
Sure,
patient
sir.
hearing and your very interesting questions, and the organizer also for inviting me for sharing my thoughts. Thank you once again. Have a nice, great day. Thank you.
Okay. Thank you, sir. Yeah. Okay. For all the participants, I invite Leah to actually say a few things about the next day programs now. Leah, please join.
So that brings us to the end of day 8 of FDP. I would like to extend my heartfelt gratitude to Dr. Sunil Pandey, Dr. N.N. Shinde, and Dr. Sapan Thakur for their time and presentation. In the last 1.5 weeks, we have thoroughly discussed about the aspects of sustainable development and resource management with a variety of speakers who are experts in their field. I hope that all the previous sessions were insightful for all of you. Thank you, participants, for your kind cooperation during the conduct of sessions. The next 2 days, day 9 and day 10 of FDP, we will have our hands-on session for the building simulation software, eQuest, with architect Ashika Sultana. Kindly ensure that you have downloaded the software in your computers and check the requirements. Please notify us if you have any issues regarding the same. During the software workshop session, attendance will be recorded only at the end of session at 2 p.m. The test marks for this session will be based on your output submission done at end of each day. The daily test Google form has been shared in the chat and also in WhatsApp group. Kindly complete the same before the commencement of tomorrow's session. For any queries, feel free to contact the facilitators via WhatsApp, mail, or call. Thank you and have a good evening.